Hi, good morning. Yeah, that was not good. Try that again. Good morning. It's better. Not good, but better. I'll take it. Hi, I'm so glad we're all here. We don't have a lot of time though, so let's get right underway. I'm so sorry for those awkward technical difficulties that I just experienced. Brain's not quite, I've had, I don't know, it's the jet lag plus the excitement of being here and all that stuff, It's been a whole year since we were here, It's been a very, very long year since we were all here at Devox, and I'm just really happy we get to be here together. How long does this thing go? Until noon or 12:30? Do we know the actual timeline? We'll figure it out later, whatever. Anyway, my name is Josh Long. I work on the Spring team. I work in my capacity as a Spring developer advocate. I'm a Java champion, a Kotlin Google developer expert, alumnus, and a Microsoft MVP. And yes, nobody is more surprised about that last one than me, okay? Look, we all do things we're not proud of. We all do things that we regret or don't really quite understand. And anyway, yeah, I am also a YouTuber. So there's that. Okay, you can find me online here on Coffee Software. Join the adventure. It's not the worst mistake you can make. It's a little watering hole on the internet where we can talk about software, this, that, and the rest. Okay. How many of you are using YouTube? YouTube. Anybody? Okay, good. I just got on YouTube like in the last couple of years, and I think all the kids are like on the TikToks and the Instagram. I don't know. I feel like I'm perpetually on the wrong place. But whatever. Find me there. It's a nice little corner of the internet, and we talk about software, and that's what we're going to do today, really, as well. So there's that. Let me see. We have, if you have questions, comments, feedback, whatever, you can find me there. I'm very much online. How many of you have email? Email. Okay, good. Find me there. And then Blue Sky. Anybody who's using the Blue Sky? Good stuff. I like Blue Sky. The community is nice. And then there's that Tire Fire. And then, look, the code for what we're going to look at today is here online. You can find it for your own reference, your own edification. I'll be honest with you, the code is not all there. We're going to kind of build up the code today, and I'll chuck all that into the Git repository once I get off stage, okay? So it'll be there for your own reference later. For now, it's kind of an IOU. It's a placeholder where you would otherwise get code. And my goal today, my friends, is just to we've got a few very short hours in which to look at a lot of different things. And so my goal is to just go as quickly as possible. To look at everything. So first things first, how many of you are using Spring? Okay. I can't see if that's everybody. Let me try again. Who's not using Spring? Okay, there's a few of you. Okay, we'll go very quickly through the absolute basics. But my goal is just to kind of give you a really roving tour of all that is new and novel in the Spring ecosystem. And bear in mind, there's a lot of good stuff this week from the Spring team, from myself, from the Spring AI team, etc. So this won't be your only bite at the apple, so to speak. There's a lot of good stuff. But it will be your first, by definition, since we start today, okay? Okay, so my goal is to kind of introduce us to a lot of different things here, my friends. And so to that extent, in that spirit, I want to have a quick discussion around desk checks, right? Getting set up so that you have this stuff at your own desktop for later. I'm using a Mac. How many of you are using a Mac? Okay. How many of you are using Linux? Okay. How many of you are using Windows? Okay. So there's a lot of you. So I'm using a Unix-like environment, right? I'm using Unix-y stuff, obviously. You don't have to, but life is easier if you are on Unix, right? Because you deploy to Unix, so it's nice to have that software work sort of the same way on your desktop environment. And so even if you're using Windows, you can use Cygwin, or you can use Windows Subsystem for Linux, or whatever. Lots of good stuff there. And then the question then is, oh, hi. Yeah. The question then is, how do you get your environment set up? And so obviously, I'm using SDKMan.io. How many of you have heard of that? Okay, so it's very, very convenient. You go to SDKMan.io. You can download a tool or install a tool called SDK, and there you can say SDK list Java, and you can choose what version of Java you want to use. In this case, I'm using Java 25, but I'm using the GraalVM distribution of it. So I went SDK, install Java, and then 25 Graal CE. That gave me the current version of Java that I want. And then I said SDK default default Java. Come on. There you go, that one, right? And that's it's the current version of Java throughout my entire operating system, okay? Now you might be using one of the other SDK distributions. So if I SDK list Java again here, and you can see there's for example, maybe I want to use this one. This is Java 25, okay, from OpenJDK, right? So if I do SDK use Java here, right, I have to do SDK install Java, that one, Wi-Fi permitting, okay, wait for it. Don't torrent, whoever's torrenting, please pause, okay? So I can install any version of Java I want. Now, the reason I like SDKMan is because it lets you create project-specific configuration. So let's say I go over here to my desktop, and I've got a new app that I'm building, so I go into the new app folder, and I say SDK use, let's say SDK list Java, okay? And then I decide I've got some old version of Java, right? Like something that nobody would ever use anymore, but that you might have used in the past, right? So for example, maybe I've got Java 24. Well, again, nobody would use this anymore, right? It's very old software. It's from the distant past. So let's say I say SDK use Java 24 open, okay? So now in this shell here, I've got Java 24, and I can do SDK env init, right? And that'll actually write a little file here called SDKManRC, writing out the details of which version of Java I'm using. So now if I go over here, new shell, I say Java version, Java 25. I go back up, Java version, Java 20, sorry. Here, let me close that, there we go. So now I'm using Java 25, all right, Java version 25. Now I go to the desktop new app, and now Java version, Java 24. Yeah, see how nice that is? So the goal is to set up your environment so that people can clone run your code. You want people to be able to take your code and start working on it really, really quickly. So SDKMan is really nice for that. It's very easy to manage versions of Java and set it up so that when people use that version, they can get going pretty quickly. Another thing that I love to use is DIRENV. How many of you have heard of this? DIRENV, okay? And the idea behind DIRENV is that you can say DIRENV, actually you can just do this. You can do NVM NVRC, I think, right? So I can say echo hi devox, right? And then I can I back out to another folder, and I go back into the new app folder, and now it's saying, hey, there's this thing called direnv configured here, and if you want to run it, you can. So I say direnv allow, and then it runs that. So now that I've in this shell, in this session, I go back out, and I go back in, and it's going to run that again on enter, right? So it ran hi devox. Why is that useful? Why would you want to run arbitrary commands when people set up a CD into that directory? Well, because now you can set up environment variables, right? So again, we have Docker, obviously. We're using Docker. I'm going to take that for granted today. Docker or something like it, an OCI container runner thing. But, you know, not everything is going to be local, right? You're going to have, you know, your cloud infrastructure somewhere, right? You might have an S3 bucket on Amazon. You might have, you know, some AI model from Google or something like that. You might have something in the cloud just for your development environment, and you have connections and credentials there that you want to be able to connect to. Well, set up environment variables, and then use that to initialize the state of things. Now, where would you keep that data? Where would you keep that environment variable? Well, keep that in your password manager, right? Most of your password managers have APIs. They have CLIs that you can use. So I have I'm using Bitwarden, right? So Bitwarden, I can actually get access to keys in my Bitwarden password manager using the BW CLI, right? So let me see if I have an example here that I can show you without opening up my password manager. So let me see, cat, what's a good example that's like, envrca, let's see, this one. So if I nvm env, okay, and now let's say I want to have an environment variable here called, I want to get this key for this thing I'm using, okay? My key, okay? I can say bw get password, and then, you know, whoop, I can do that, okay? And then the password manager, the name of the item in my password manager, I put here. So my PW, okay? So if I do that, this will actually call into my password manager. Now, of course, I need to be authenticated for that to work. And so do I want this to be my default? No, okay. Where's the, let's see here, what's the, hold on 1 second, okay? I'm gonna unplug this HDMI cable for just a half second so I can like, I have a generic one here. My password, work, deep dive. There you go. Here we go. Okay. So now I've got this Bitwarden password manager open, right? And you can see I've got a demo here, this Bootiful workshop demo. And I can see the password here. I've opened it up, and I want to get access to this item here, right? So it's Bootiful-workshop-demo-key. So I go over here, nvm. Let's see, desktop new app. Okay, nvm.envrca. And didn't I already have this running? I did. So it's called Bootiful workshop demo key. Okay. And DRM allow again. Okay, and it's going to ask me for my password to authenticate with my password manager, right? Oops. Did I get the name wrong? Bootiful workshop demo key. Yeah, it's there. Oh, it's a different syntax. Okay, so echo. Let me see. envrc. So nvim.envrc get item, I think. There we go. Here we go. So it's called, get rid of that. Okay, what about now? Let's see if I did that right. DRM allow. Not found. nvim.envrc. And then, I don't know, something like that, right? You can use this, I'll get it eventually. You can Google it. But the point is, you can load things from your password manager into your environment variables. And so when people CD into the directory, if you have a shared password manager, okay, did that work? Let's find out. There we go. So I've got some JSON, and then you can use JQ to get access to the password right there, okay? So it's very easy to script shared credentials that people have, so when they CD into this project, they can get access to the S3 bucket for development, right, or whatever. This is important. This allows everybody in the team to start working in your code really quickly, okay? They have the shared environment variables. So now, if I want to start writing code, I use my IDE. I'm using IntelliJ, but you can use Visual Studio Code, you can use Eclipse, you can use the Spring Tool Suite, whatever. If I start IntelliJ from this directory, it now has access to the environment variables that are set in that shell. So now when people run code, those environment variables are there, and they can be used to configure your connections to your data sources, your S3s, from within your program. So how do you get your program? What's that look like? Well, obviously, I recommend you go to start.spring.io. Here's my second favorite place on the internet, obviously. My first favorite place, production. I love production, right? And so here, this is actually a web service, start.spring.io is. You can go here, you can say curl, and you get access to a menu that, specifies all the different starters that are there. You can use that. And there's even some sample curls here, right? Like on how to set up a generic project with nothing in it, or Java 11. This is not supported. Java 11 is just an example from the distant past. There's no Java 11 today, right? But my point is, you can do everything from that web service. In fact, you can create your own version of this. This code is open source. So Spring Initializer is on Spring.io, the GitHub. Okay, here we go. That's this right here. You can clone this. You can actually create your own Spring initializer, start.spring.io. You can git clone this, configure the properties, right? You can see there's actually, this is an auto-config library. Our implementation of it, here, let me do that. Our implementation of it is start.spring.io, right? So we're actually using one library to set up the start.spring.io experience. This is also open source. You can see it's public, right? And there we have, I think it's the site, is the actual API, that's the Spring Boot API, using the starter that is provided by the initializer library. And then the config for all the different checkboxes and all the different supported dependencies is this giant YAML file, application.yaml. So you can do the same thing. You can have your own start.yourorganization.io. You can configure which dependencies are supported. You can remove the dependencies that don't make sense for your organization. Maybe you've standardized on Google Cloud or AWS or whatever, in which case it doesn't make sense to have all the other ones there, right? You don't want people in your team selecting something from whatever, Azure or Google Cloud or AWS, if you're only using AWS or Google Cloud or Azure, right? So you can actually remove those. And that way your team, you can only generate new projects that make sense for your organization. Likewise, if you have your own dependencies that you want every new project to have, you can specify them here, right? In your own starter, your own start.yourorganization.io. So now when you go into IntelliJ, if you go to Visual Studio Code, if you go to Eclipse, all of them have wizards, to create a new Spring Boot project using the Spring initializer. Those wizards all take the URL of the initializer. By default, it's start.spring.io, but it could be your organization's initializer, right? So when you create a new project, all roads lead to start.spring.io, right? And you can customize that as much as you want, or you can use the default, it's fine. I'll be using that a lot today. We're gonna go through and start new projects very quickly. Which, to wit, let's do that. I'm gonna build a new project here, start.spring.io, and our goal here is, I just wanna build something here. Let's just, let's talk about, let me see, start.spring.io, there we go. I'm gonna build a new application. I have some choices to make, as always, right? Before we get too far down the road, I wanna build a new application. I'm using the latest version of Java. I'm using Java 25. How many of you are using Java 25? And how many of you are wrong to use something else, right? Who's using Java 25? It's been out for a month. Come on, people. We're almost 15% of the way until Java 26, right? Java 25 is awesome. It's an amazing, amazing release. It's also a long-term supported release. So if you're gonna settle on a version of Java, that's the one to land on, right? Really, really good version of Java. Lots of cool stuff. It's also just years in the making, right? There's a lot of really cool features that have landed there. One of my favorites is that now there's new support for writing JavaScripts, okay? Now these are the only good kinds of JavaScripts, right? You don't want to write the other kinds of JavaScripts, okay? So what I mean by that is this is valid code. So let's go over here, hello.java, okay? Open that up, and I shall say void main, okay? And io.println hi, okay? And then I can just do Java, hello.java. Which version of, which shell am I in? See, Java 24. Never use the old stuff. There we go. Move new app, hello.java to script.java, okay? See, cat script.java, move script.java to script without the space. There you go. So now Java script.java, okay? There you go. So I didn't compile it, right? First of all, I just did Java. I did Java script.java, okay? So I didn't compile it, and then the code for that is just this. It's just void main. No public static, right? No string arguments, and like me, no class, okay? Very, 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 very convenient, right? So you can write JavaScripts. These are the only appropriate and good kinds of JavaScripts now, okay? If you do the other kind, I will think less of you, okay? So JavaScripts are really, really quite powerful. And actually, if I move this script.java to just, let's say, script, okay? And then I chmod ax script, and then I open this up, this script that's written in Java, this JavaScript, user bin env -s to tell it to tokenize the spaces, right? Java source 25, right? Now I can just do that, okay? So now I've got a real JavaScript, the only good JavaScript, okay? Just take that. When you come away from this conference, for one thing, remember, we finally have JavaScript, good JavaScript, okay? It's an amazing time. Now, this is pretty good, but what if I wanted to do something real? I mean, you might have noticed, like, this is not bad. I mean, it's gotten a lot more concise. One of the things that's nice is that in Java 25, they took all the interesting I/O stuff and put it under I/O. You can still do system.out, blah, 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 but, you know, this is really nice. It's very convenient, and it's automatically, implicitly imported. Now, one of the other things that's nice about Java 25 is that there's now support for importing Java modules. So you don't have, don't freak out. I see like people crying and whimpering and leaving. Don't do that. You don't have to create modules, okay? But I'm saying if somebody's already created them for you, you can import. You can say import, module foo, right? Something like that. And what you'll do is you'll get all the types inside the module there, every one of them. So for example, java.base is a module, JPMS, Java Package Module System, right? It's a module. It includes everything you would need to be useful, like the vector API, the collection APIs, all that kind of stuff comes in implicitly. So if you want to write a JavaScript and you want to use collections, you want to use the primitives and all this other good stuff that you would need to do most programs, that's all there. Just import one thing and you get all these types now. So it's module import syntax. Much nicer, right? So the question then is, okay, well, I can write really interesting programs without actually opening up a full-fledged IDE. But what if I wanted to write more interesting programs that used libraries? Well, now you get into a whole thing where you have to have dependencies on the class path and all that. And you could certainly do, you could say -cp space and then pass in the class path dependencies. But then you sort of get into, it gets a little much, doesn't it, right? So one of the things I really like, there's this great project called jbang.dev. How many of you have heard of this? Jbang, okay? Jbang is awesome, right? This is really, really good. It's a utility, it's a preprocessor for JavaScript. And so I actually happen to have desktop misc talk, is it this? Okay. Did I put it in the desktop? DevOps. This one. Okay. So I happen to have another script.java here. And this one is a full Spring Boot application, but I'm using the JBang preprocessor. So what's going to happen is it's going to go through this script.java and it's going to process these commented directives at the top of the source code to tell it to download Java 25, tell it to use preview features. I don't need to, but in this case, but I could. And it's going to download the Spring Boot starter web from Spring Boot, and it's going to download the source code. It's going to do like an include on the source code in this extra folder here, okay? And this is actually something that Dr. Dave Sire and I put together. So it's a little glue code, but basically instead of having Spring application.run, you have Spring script.run, right? So now I can just, you can see it's a top level class, a controller, right? And a top level bean definition. There's no container configuration class there. It's just a bean definition floating in midair. Isn't that nice? And then Spring script.run. So now I can do Java. What is this file called? This is called script.java. So javascript.java. What happened? Java version. Desktop. Where am I? Here we go. Desktop. Java. Oh, it's just actually this one, script.java. Let's try that. There you go. So it's downloading everything. There you go. Now I have a web server, and my standalone Spring Bean started up. And now I go to localhost, and there's my HTTP endpoint, right? So that is, if I take this, like, if I copy script.java to the desktop, I've just got this script.java, just run that, and again, it's just one little source code file, and it's a Spring Boot application, okay? one source code. Again, so things are different now. You can do amazing things now that you just couldn't do with that other JavaScript, the bad one, right? Like we live in an amazing time. Okay, so Java 25, really nice. There's a lot of other features, don't get me wrong. I like this one because it just makes it so you can start building interesting things really quickly. And by the way, I use JavaScript all the time, right? I have several in my operating system that I use just for day-to-day stuff. Have you ever written Bash? Anybody here ever written Bash? Yeah, I'm sorry. Exactly. Yeah, we've all made mistakes. It's not good, okay? It's never been good. It's there, right? But that doesn't mean it's good. You know what else is there on most Unix or Linux distributions? PHP. You don't hear me like raving about that either, right? There's a reason. It's terrible. So yeah, we can now write JavaScripts. You can do system administration using Java. So let's build an application. Back to this. I shut that down. Good. Close that. Now I'm going to build a new application. And the goal here is to build an application that demonstrates a bunch of the really cool features in Spring. Like I said, I want to build an application that does something useful. And obviously, in that vein, obviously, I'm looking for something that's sort of easy to understand and easy to digest and dive into. And I thought we could look at the old Spring Pet Clinic. How many of you have seen the Spring Pet Clinic sample application? The problem is, this is just too much. I mean, it's been updated, don't get me wrong, this year's 3 months ago, but there's just too much of it, right? If you go actually to this folder here, this GitHub organization, you can see that there's like dozens of different variants of the Spring Pet Clinic here, demonstrating all the different possible implementations. Here's Kotlin and REST and microservices and Spring AI and JavaOQ and Istio and GraphQL and, I don't know, Angular and, well, I mean, just, there's too much. Too many different versions of it. But I do like the domain. I love the domain of animals. I love dogs, cats, animals, that kind of thing. I'm a huge fan. Big fan of cool animals, right? And so I thought we could do something in that same spirit, right? And I love animals. I mean, I just love animals so much. I love almost all animals, okay? Almost all of them. Every one of them except my dog. Just the worst dog, okay? Not a big fan. I mean, actually, I even love him. I just don't like him. You know what I'm saying? Like, it's one of those things. He's family, but not all family is good. You know what I'm saying? So this dog, the worst dog. The worst dog. I mean, not a good dog at all. I think he's I don't know what his deal is. He's a very strange little guy, you know? And he's over there conspiring to do terrible things to all of us. But nonetheless, he exists, you know, and so we love him even if we don't like him, right? So we love him for 3 simple reasons, even, you know, very, very simple reasons. One is even terrible dogs deserve love, right? So that's true for him. His name is Peanut, by the way, Peanut the dog. So that's part 1. Part 2 is ego, okay? Just gonna be real with you here. Ego is very, very clearly a part of the situation here. In my home, my partner and my daughter both speak 5 languages. I only speak 3.5. So if we didn't have that stupid dog, I would be the dumbest in the house. So that won't stand, okay? That won't stand. And then finally, the third reason is, and again, just being real with you all here, just being honest with you, he is very, very cute. Okay, so here's a photo of him being super cute, right? Or look how unhappy he is. Yeah, you can see a common theme. He's got little yellow ducks in all of these photos. These are different years, you know, and he's obsessed with these. And if he could replace all the human beings in the house with yellow ducks, he would, right? He uses these as sort of like landmines. He puts them on the floor, and if you step on one of them, he can hear you, and you will lose a foot, right? He'll take your foot from you. So it's not a good dog. He doesn't make the overall experience of living in the house better, but he is very, very cute. So we love him, and he reminds us of another dog. It reminds me of another dog about which I learned during the pandemic named Prancer. And Prancer also sounds like a bit of a handful. Prancer's owner at the time put out this ad back in April of 2021 trying to find a new house for this dog. And she describes this dog. She says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer because I'm tired, and so is my family. Every day we live in the grips of the demonic Chihuahua hellscape he has created in our home. If you own a Chihuahua, you probably know what I'm talking about. He's literally the Chihuahua meme that describes him as being 50% hatred and 50% tremble. If you're intrigued and horrified at how this animal sounds already, just wait, there's more. And she continues on, I won't read it all for you, but she says, as awful as it sounds, I kind of liked him better that way. He was quiet and just laid on the couch. Didn't bother anyone. I was excited to see him come out of his shell and become a real dog. I'm convinced at this point that he's not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home. Whew. So this is borderline dog slander, okay? This dog probably doesn't deserve all of this, but one sympathizes, okay? It sounds like a bit of a handful. Anyway, and so she continues. She says, this dog, let's see, he's never been in the presence of a child, but I can already imagine the demonic noises and shaking fury that would erupt from his body if he were. Prancer wants to be your only child. And she continues, I know finding someone who wants a Chucky doll in a dog's body is hard, but I have to try. And she continues and signs off, warning, oh, he's only 2 years old and will probably live to be 21 through pure spite. So take that into account if you're interested, right? And to be fair, that's a very cute dog. I would totally pet that dog. I might lose a digit, but I would totally pet that dog. So I think about this dog a lot as well, because this dog, like my dog, sounds like a bit of a handful. And this dog, unlike my dog, went viral, right? So here's, this is People Magazine. I don't know if you have People Magazine over here on this side of the Atlantic, but it's a pretty okay magazine back home. And so here, People Magazine talked about Prancer, the demonic Chihuahua's new owner, says he helped her heal from past trauma. Now, I know did you read that headline correctly? Somebody adopted Prancer, by the way, spoiler alert, somebody adopted Prancer, and then that person said that this terrible, terrible dog helped them heal from some other trauma that they'd already had. And I think that's a bit like have you heard of the nonsensical suggestion that if you want to cure a headache, you can just stub your toe, right? Because you won't feel the headache anymore. And I think that's sort of what's happening here. I don't know how this worked out. I would be interested in knowing. Nobody tells me anything. Here's a USA Today, right? USA Today. Oh, Bubby. Anyway, so this dog. So yeah, this is USA Today, a newspaper that discussed this dog. Here's BuzzFeed, right, talking about we caught up with Prancer, the viral. Oh my God, I'm definitely back in Europe. I have accepted more cookies in the last 5 minutes than I did all year. We caught up with Prancer, the viral nightmare of Chihuahua. We found a story of redemption, right? And here's Prancer again, looking really adorable. And then, of course, here's the New York Times. Like, the New York Times, you've heard of the New York Times. Here's Prancer, go away. Okay. Prancer, the demonic Chihuahua, finds a home, and an adoption ad said he was literally the Chihuahua meme that describes him as being 50% hate and 50% trouble. Anyway, my point is he went viral, okay? Everybody knew about this dog. And so I think about him a lot. I want to be able to build a system to support adopting dogs. So we're going to build a system to do just that. We're going to use the latest and greatest versions of Spring and Java and all that. But we're not using the early access stuff. And there's going to be people here this week talking about the new versions of Spring Boot and Spring Framework and all that stuff that's coming out in November, right? That's next month, the early access snapshots. And so I wanted to cover some of that right now, but be sure to catch the detailed sessions on that. So I want to talk about and also we're going to talk about the intro to Spring and just basic configuration here. So I'm going to use 4.0 M3, okay? Milestone. This is the only thing I'm going to make sure to cover using the new 4.0 stuff. Everything else will be against the GA 3.x stuff that you can deploy to production today. Okay, so I'm going to use Java 25 and Spring Boot 4.0, and we're gonna call this basics. Okay, and maybe I'll bring in the web support. Who cares? Open that up. Downloads UAO basics.zip. Now UAO again is an alias in my shell which points to, you guessed it, a JavaScript. Okay, so again, all that JavaScript does is unzip and open. You can kind of figure that out, right? So it's just a void main, finds the zip file, shells out, calls unzip, finds the build file, shells out, called IDEA, and so on, okay? So now I've got this open in my IDE here, and let's just talk about Spring basics, just a quick primer on the basics here. The idea behind Spring is that you have a framework that is a framework for building frameworks, and at the core of that is this idea that you have a bunch of objects in your system that need to relate to each other. They have dependencies on each other, and they have life cycles. Spring manages that life cycle for you. Why? Why not just create the objects yourself, right? It's not that big a deal to do that code, right? And the reason is, if you take the time to tell Spring about how these objects are created and how they relate to each other, Spring can do things for you on your behalf. It can intercede on your behalf, thanks to the magic of polymorphism, right? The very core idea behind a strongly typed object-oriented language like Java and Kotlin and so on is that you have a little bit of misdirection that can happen between when you create the object of type foo and when somebody depends on that object of type foo. Because as long as it's a foo, they don't care if it's a foo with extra superpowers or if it's the regular foo that you created or what. As long as it's compatible, as long as it's polymorphically compatible with foo, right? And that's where Spring can do a lot of really interesting things for you. And the way we do that is by creating basically subclasses for you. You don't see it, but that's what's happening. Or we implement interfaces for you, right? So Spring dynamically creates a bean or a class that extends yours and adds new behaviors there. Or we can just find your objects, and because Spring has a visibility into all the objects in the system, we can consistently apply services and capabilities to all these objects. So yes, you do have to do a little bit more work. You have to tell Spring about how the objects in your system are created, but for that work you get a lot of benefits. And to be fair, you just need to tell it about the objects. Most of the time, you don't have to change the shape of your objects so that it works in some sort of hierarchy, right? We talk about, and we've always talked about, POJOs, plain old Java objects. These are just regular Java objects that have your method signatures aligned with your business domain and your concepts and your APIs and so on. And the benefit of that is that the code is as you expect it to be, not as Spring expects it to be. And so we do our best to apply these services for you based on the shape of your code and the presence of annotations. So these are signals that you give off to tell Spring that you need certain behaviors there, okay? So what do I mean by that? Well, let's suppose, just very simply in the abstract term, I've got a class foo, right? And I've got a class bar. So in the old days, in the very distant past, you could have created an XML file. Please don't do that, okay? I mean, how many of you remember Spring and the XML files? Yeah, okay. It's been decades. You don't need to use that. So what else how else could I do it? Well, I could create a config, Java config class, right, like this. I could say at configuration, and what happens there is you create these Java config methods, okay? So, and those two methods now tell Spring that it's going to manage an instance of bar and to manage an instance of foo. Well, what if I have a dependency? What if foo depends upon bar? So final bar, add that to the constructor, okay? And now I need to inject a pointer to bar, so I add that here, bar, and voila, okay? So I'm telling Spring, okay, create an object of type foo, it depends on type bar, find the other bar in the context, and then provide me that instance. Now what if I want to get another instance multiple times? What if I want to use that instance? Well, or what if I have multiple instances? So you can actually tell Spring, hey, give me all the bars, give me an array, right? Or you can say, give me a map of bars with their bean names. So I get now the name of the bean, which is basically the method here in this case, or it's the name that you provide there, my bar, right? It'll give you this as the key and then the instance as the bar. So if you have 10 different bars in the context, you'll get them all injected there for you and made available. So bar 1, bar 0, etc., right? So now of course you have to choose which one you want. The other approach that you could use is to say, hey, I want just a particular bar. I don't need all of them. So here I can use something called a qualifier, right? I can say my bar, and that'll give me only the my bar with that bean name, okay? And if you don't specify the bean name, then the name of the method is used to create the instance there. Now, this is a magic string, so that's not great. I mean, you could do something like this. You could say bean name is my bar, and then do bean name, bean name, and then inject that here, and then let's see. Now you've got a constant, and that's a little bit better. They can both share the same string. So if you change this, it'll be updated elsewhere, right? So whatever, right? You could do that. But I don't know. Some people might prefer something more type safe. So another option is you can actually use Spring's meta annotations, right? So this is @qualifier. It tells it to disambiguate from among a field of possible candidates one particular version. Well, this is a meta annotation as well. And what I mean by that is I can go here, copy and paste that annotation, paste that there, okay? And I'm going to say devox, bean, okay? Well, now, if I just add @qualifier to that, right, and I put that on this, I can say @devox bean bar, and let's see here, what have I done? Oh, okay, yeah. Now I go over here, and instead of using the bean name, I use the qualifier. I use the meta annotation. I say devox bean. Okay? Get rid of that. So now I've done that. I've got these two different annotations. Spring this is the producer, and it's got a qualifier on it. It's got the meta qualifier. It's a qualifier on the annotation, and that's good enough. And then here at the injection site, I'm telling it to use that. So now you've got this type safe link between these two things, right? So you can do lots of things to pick from among them. And it's pretty flexible. But what if you wanted to have, another thing you could do is you can actually call this method directly, right? If you didn't want to do all these shenanigans to try and figure out which one to inject based on some other signal, but you happen to be in the same Java config class, well, I could just inject it. I could just call the method. So var myBar equals this.bar0, for example, right? And I can pass that in. Right? So now I've got two bars, but I've made very clear which one I want. I want bar 0. Now what happens if I do that? So I system out creating bar 0, and what happens if I call this method 1,000 times? Right? I0, I is less than that, this dot bar 0. Okay? So we'll do that and there. So let's actually start this program up and see what the behavior there is. Okay? You can see it says creating bar 0 one time. Right? Even though I called that method 1,000 times. Right? So what's happened there? Well, Spring starts up and it creates a subclass of this config class, and it overrides this method, this method down here called bar 0, and it calls super to call this, but only after it's checked a cache. Right? It memoizes the bean that's been created and returns the pre-created instance unless you give it a different scope. Right? So Spring has this concept of scope. Scope, here you go, singleton, right? So if I do that now what happens? Okay. Creating bar 0. Scope. Did I call the right method? Singleton. No, I'm sorry. Prototype. I'm so sorry. Prototype. Okay. Now you go. See? Now it's created it's going to call the method and create it brand new each time I use it. So by default, unless you specify a scope prototype, the default scope is singleton, which means there's only one instance of the bean in the application context. There's a life cycle that Spring is managing here for you. So you can call this method all you want, but it's only going to get the same instance over and over again, right? So now you can use Java config to decide which instance you want, right? You have that. And did you know you can actually inject Java config? So I can say class my other config at configuration, and I'm going to create a bar. I'm going to create a foo rather. Okay, and I'm going to decide. I need a bar, so I can call the method here. So let's see if I cut and paste this over there, put that here, here. And now I want the configuration class that contains the definitions for my two bars. I'll call my config, and I can now go over here, comment this out, and I can say myconfig.bar. Okay, and the same rules apply. So if I do for var I is 0, I is less than 1,000, myconfig.bar bar 0. Okay, let's try that. Okay, same rules. I'm still getting just one instance, even though I injected it. So Spring will let you actually inject the surrounding config class, and you can dereference the bean methods there yourself. Now, of course, you might be wondering, well, what if I wanted to call, what if my bar 0 itself took another dependency? And there's a lot of well-known objects in Spring that you might want. Like, for example, the environment is a dictionary of keys and values that, well, they represent your environment. And I might use that. I might say, give me this property called java.version, okay, version. So I can print that out. So the version is version, okay? Well, now I've got this dependency here, right? And let me get rid of that. Get rid of that. So now I'm over here. I'm calling bar 0, and I need to provide the dependency. Well, I could do this. I could like cascade the decision. But did you know you can actually just pass a null, right? Since it's going to be pre-computed anyway. So you're just telling Spring, I want the pre-computed version, right? Version is 25. And it doesn't matter if you pass a null again because it's already pre-computed. The actual version was working there. So now you can be type safe. You can actually call, I want this bean method, and I want the result that comes from that bean method, and so on. I get the single memoized singleton version. Okay, so now we've got Java config. This is, this has been here forever. Obviously, Java config is not new. It's been here since 2009 in Spring Framework 3.0. Obviously, you're not going to create everything with Java config. You might want to let some convention help you out. I've got a foo here, right? And obviously, I'm doing a lot of fun things with qualifiers and all that kind of stuff here. But let's say I wanted to actually, what's another example? Maybe I want to create the bar. Maybe let me just create a baz here. We'll create a new one, right? Baz. And I create a new constructor. And I can just say system out baz, right? So now I want this object to be created. Well, I could create a Java config method again, but we have also component scanning. And so the idea there is that if you create a bean and you annotate it with @component, as long as you've got somewhere you've got @component scan in the application somewhere, then any bean, any object under the current package or beneath it that has @component will get picked up. So now I can just do that, and you can see Baz got created as well, right? Now, obviously, we already have component scan. That's actually on this annotation. So if you look at Spring Boot application, and then you look at this, you can see it's got Spring Boot configuration and component scan and configuration, right? Component scan is picking that up. So this is actually a little redundant, isn't it? I don't need that there. So let's restart again. And you can still see that Baz was picked up. So we have component scanning, which finds things based on convention, based on these marker annotations. This is a marker annotation or a stereotype annotation. When I say stereotype, I mean from UML, right? Stereotypical. It's got a role, okay? Now, these are also meta annotations. So if you have @component, what if you wanted to say that this is not just a component, but it's an actual business service? Well, just use @service. @service is a meta annotation. It, in turn, is annotated with @component. So if you wanted to create your own meta annotation, you could do that as well. So let's go over here, and you could say, devox. Okay. So now I've got my own meta annotation. Okay, devox service. Okay, reload that. Here you go. Why is this unhappy? There, it was just IntelliJ being strange. Okay, so now devox service, it still works, right? It's being picked up as though I had annotated it with @component, because I did. But now it's very clear, if in my organization I have a kind of component that does a certain thing, you can create your own meta annotations and get Spring to play its role, but now it's very clear what your domain is, right? So Spring is a framework for building frameworks. You can build a domain in the way that matters for your organization. You can build services and objects and so on, and components that map to your mental model, your domain model. Okay, so this is Java config and component scanning. Nothing new there. Let me get rid of all this documentation. Okay, nothing new there. One thing that is nice in Spring Boot 4 and Spring Framework 7 is there's this new thing called a bean registrar. How many of you have heard about this, the new bean registrar support? Yeah, okay, cool. So there's at least one. Basically, let's say I wanted to create my bean registrar implements bean registrar. This is new in Spring Framework 7, okay? And the idea is that you've got this component type, it's called bean registrar. If you want to bring it into the program, you can import it just like you would any other Java config, right? And here now I've got a registry and I can programmatically register beans based on, convention. For example, I can say baz.class. And if I do that, then I don't need the meta annotation there, right? So this is just a regular standalone class, but I'm registering it here now through this bean registrar. So if we restart, everything should be exactly as it was, right? There's Baz. And I can also do, let's try the foo, right? Where's my foo example? Here. So I'm going to comment this out. And I'll register that as well. I'll say registry.registerBean foo.class. Now foo, of course, depends on bar, right? And bar, as we've seen before, there's two of them. So Spring can't automatically deduce which one to inject. So if I comment out one of the bars, then based on convention, it'll automatically figure out what to pass in there, right? But if I bring this bar back, now it's going to fail because it doesn't know how to disambiguate from the possible choices. So here, I can use the slightly more involved overload here. I can say register a supplier, okay? New function. And my job is to produce a new foo using the supplier context to get the bean of type bar.class. And I can actually disambiguate here. I can say I want the bar based on the name. So this is going to be my bar1, okay? Oop. Okay. There we go. So here we go. Reload that. And reload. So now I'm going to register a foo, but I'm going to, and when Spring needs to know how to create the foo, I create the foo in the supplier, and I can look up another bean of a particular type by its name and its type here and provide that, right? So I'm getting the same benefit as I had before, but notice that this is actually much less code. I've got two bean definitions here registered. Instead of registering whole methods, I just have 2 lines, basically. I wrapped it because I'm using a small screen here, but it's just 2 lines. And also, now, if I wanted to do something, people ask this every now and then, how do I do a for loop? Well, you just do a for loop now, right? I can actually do registry.registerBean. Let's just create a class, my instance, right? String instance, and then a constructor, okay? So now I print that out. Instance, this.instance, right? So now I've got that constructor. I want to create a bunch of them, right? So I go over here, register bean, and I can say instance I, and then, this s.supplier, new function, and what I want to register is a bean of type instance. Okay, there's that. What is this? My instance. Okay, so now I've got that. Go over here. Implement that, apply. Good. Hiya. Let me just clean this out. I've made a mess. It does get a little intense if you're not paying attention to your nesting. We've somehow brought all the benefits of Lisp to Java here. Okay, let's try that again. So registry.registerBean instance plus I, and then s.supplier, and then new instance, or new my instance, passing in this version here, right? Oh, I have to capture it, don't I? So var index equals I. Why is this a problem? Look at that. Why is that the solution? And then what is this? Cannot be converted to T. So register bean. Oh, I still need the my instance.class. Yeah. Okay. Supplier. Okay, so I've got the name, the class. Oh, okay, wait. Class. I've got this. This is the other way around. Okay. And then it's my instance.class. And then finally, a new consumer here. Okay, return my instance spec.supplier, new function. Oh boy. 500 levels deep, but it's like the inception. Okay. Clean that with lambdas. There you go. Lambdas. Simple. Okay, well, whatever. You can see the power there, right? I'm now registering 100 different beans, right? So let's go ahead and start the program up again. And so you can see now I've programmatically registered that. Now, why would you ever do that? I don't know. But people ask, right? They want to be able to do that. I don't know why. Maybe you want to call a database and create objects based on something in the database or something. Who cares? My point is you have that flexibility now, right? And the fact that it's the same exact abstraction as what allowed you to do this, which is very concise, it scales, is I guess what I'm trying to say. You now have the ability to start small and be a lot more concise than what you were doing with Java config. You can move to slightly more complex with more stipulations. Like this, this thing right here is actually very rich. You can actually say, I want it to be, here's my description, and I want it to be, all sorts of stuff you can specify. What is it background in it? Is it lazy? What's the order? Is it a prototype? Is it a singleton? Blah, blah, blah. You can specify all the stuff that you would specify in XML, in Java config, in bean definitions, and so on, with as much verbosity and clarity as you want. And you can even do like if, else, while loops, all that kind of stuff. So I think this is a really nice programming model, and I can imagine it being, I don't know, I feel like for the simple stuff, this is actually less code than before, so I might just use that. Okay, so that's new in Spring Boot 4. Okay, so that's Spring basics, component model, dependency injection, all that stuff. One last thing you need to understand is that when I use Spring Boot, I'm using Spring Boot, and it provides Spring Framework. It uses Spring Framework. It provides all that configuration. That configuration is nice. It gives you the flexibility to do what you want, but the real power of Spring Boot is this thing called auto configuration. So if you look at on the class path, you've got this files called autoconfiguration.imports. And it used to be, like for example here, it used to be in Spring Boot 3.x and before that we had one big jar called spring-boot-autoconfigure. And then that had every single auto configuration class in existence. All the Spring Boot config lived in one jar. Now these text files list Java config classes like the ones I just showed you. So if you look at this class here, you can see it's just a regular Java config, right? It's just a configuration class that defines beans for you. So @bean. The difference is that these beans have tests, conditions that short circuit their evaluation if these tests are false. So for example, here we're saying create this bean called ordered hidden HTTP method filter, but only if the user has not created their own, that is to say the user is you and me. If we have not created our own bean of that type, then this will be created. And if the property is not set to false, if this property is not false, then this will be created, right? So Spring Boot provides these conditions that you can use to back off or to stop or short circuit the evaluation of these different beans. And that means that you get a lot of defaults out of the box, but you can override them at every turn. So if you want to create a Spring application that has these that has a web server and data access and all that, you'll get that by default out of the box, but you don't have to worry about it like being an inflexible thing. You can override it as well by creating your own objects of your own types. So that all those auto config classes come in these jars. It used to be you had one big jar full of every auto config, and every single test would be evaluated on every startup, right? But now in Spring Boot 4, we've modularized it, right? So the auto config for servlets lives in a jar called Spring Boot Servlet, right? And now, as a result, you can actually make more granular decisions about what you want to bring on the class path. One thing that people complained about before was, hey, I want to use just the REST clients. I want to call a web service, but I don't want to build a web server, right? I might be in a Spring Batch application or a microservice or a Lambda. I just need to call a web service, but I don't want to start up a web server, right? I'm just trying to be a client to somebody else's web server. And so now, because the auto config is no longer all in one monolithic thing, I can bring in the REST client support, right? So if I do that in Spring Boot 4, you have this new starter, Spring Boot Starter REST client, right? So not only is it better granularization, but it's also going to result in a bit of a performance improvement when you start up, because we don't have to load and then evaluate all these different Java config classes and conditions on every single startup. Okay, so Spring Boot 4, lots of other stuff, and I'm sure you'll hear more about it. But I just wanted you to see that there's some really nice stuff underneath the hood when it comes to basic component model goodness that we just looked at. Okay, moving on. So back to our regularly scheduled programming. Let's build an application to support adopting dogs, right? And so we're going to do that as always by going here, build a new service called adoptions. I'm going to use Java 25. Again, very, very clearly, right? Java 25 is technically superior in every way, okay? It's an amazing release. Technically superior, faster, more performant, more syntax rich, more operations friendly. It's technically superior in every way. It's also morally superior, okay? You won't like the look of sadness and shame in your children's eyes when they see you're still using Java 8. Okay, don't do this. Be the change you want to see in the world. Do the right thing. Use at the very least Java 25. Now, it's also mathematically superior. This is just stone cold facts. Okay, it's mathematically superior. Java 25 is in fact more than 3 times greater than Java 8. Okay, it's just a simple fact. Okay, 3 times 8 is 24 plus 1, 25. Okay, so it's just a better version all around. We're going to use Java 25. We're going to build an application that uses Spring Modulith. We'll use the web support. We're going to use Postgres. We're going to use Spring DataJdbc, which is an ORM technology. We're going to use the web support. And what else? Oh, I already had web. I'm going to bring it back here. I think that's it. I think that's enough. Let's do GraphQL. Maybe I'll do gRPC if we have enough time. Okay. Let's think about it. What else do we need in here? Maybe we want some Spring integration. Okay. So there's that. Actually, and you know what? Maybe I'm getting ahead of myself, actually. We don't even necessarily have data in the database yet, do we? Right? What if we didn't have data in the database? We want to have data in the database. And so let's actually go back over here, start.spring.io. And before we get underway, before we start building the service to support adopting dogs, we need to load the data into the database. So I will create a simple Spring Batch application here, okay? How many of you have heard of Spring Batch? Okay, it's a very old project. It's awesome. It's been around since 2006, I think. And it was created by the Spring team working with Accenture, if memory serves, right? And the whole point is, one of the truisms of the world is that for some reason we always reinvent batch processing technologies that have been around forever. Every generation seems to do a terrible job of forgetting and then reinventing the same thing over and over and over again. So we didn't want to perpetuate that cycle, but there was no good story for that in the Java ecosystem back in 2006. And so we created Spring Batch. And the whole point is, anytime you're dealing with large amounts of, but finite amounts of data loading, then you need batch processing. So batch is basically just any amount of dealing and processing with data, okay? So I'm going to bring in Spring Batch, I'll bring in Postgres, I'll bring in the JDBC support. And okay, let's open this up here. Okay, UAO batch.zip. I'm going to open that up. And what I want to do is I want to support loading the data into a database. So I've got now to connect to a database, okay? Can you see that? Yikes. There you go. So we'll say Spring Data Source secret, okay? Username is my user, and URL is JDBC:/Postgres. And it's my database, and I'm not using MySQL, so good. And okay, so there's my connection. And one of the things I like about IntelliJ, you can just click on that little button there, hit test, hit apply, hit OK. Okay, and I've got this table public tables, and I've got this table called dog. Let's drop that table. Okay, tools. No. Let me just use this shell here. Hello, drop table dog. What could go wrong? Okay, so now I have no dog table at the moment. Okay, and what we have to do is to, from whole cloth, recreate that table. So I'll go over here, and I'm going to create a new data.sql file, or not data, schema.sql file. Schema.sql. Okay, and here I shall say create table if not exists dog, ID serial. And the idea is that Spring Boot will, you can use, how many of you are using Liquid-Base or Flyway or something like that? Yeah, okay, so great options, right? But Spring has, of course, again, to be clear, it's not as good as Liquid-Base or Flyway, not even close. You would definitely use those for almost anything non-trivial. But you have the capability to run SQL when the program starts up, right? To run these SQL files, schema and data.SQL. So ID serial, name, want owner, description. Okay, good. So there's our data. So ID, name, owner, description. So it's let me just make this text. Okay, text. Okay, text. Okay, good. So there's that, ID, name, owner, description. Good. So I'm going to create the table. If it doesn't exist, it'll get initialized. I'll tell Spring Boot to run the SQL file when the application starts up. Here, hello computer. Initialize SQL init. Okay. SQL init. Do I not have JDBC on the class path? Postgres. JDBC. Initialize. SQL. Did they change this? JPA. There it is. Looks like it should work, right? Mode. Okay, there we go. SQL init mode as always. So I'm going to tell it to run the initialization when the program starts up. Let's see if that works, okay? Already we're going to start something up. Okay, so the program started up. Did it run this file? Yes, it did. So I've got now a table there. And what we need to do is to ingest some data and write it to the database, okay? So I'll create a Spring Batch job. Now, do I have a CSV file? Talk. Misc. Talk. Okay, find CD desktop. Misc. Talk. Find. Okay, there it is. Copy dogs.csv into the devox folder. Okay. And I'm going to create a Spring Batch job that loads all the data from that CSV into our SQL database. Okay. And so I'll say return a new job. In order to create the job, I'll have the job. It'll be dogs ETL job or lowercase ETL job. And in order to persist the state related to the job instance itself, I'll pass in the pointer to the repository, and then I'll have a single step in this case. So a job has 0 to n steps, right? And those steps in turn do things with item. They can either have a tasklet, which is like the like a generic fall through catch-all, just run a lambda or runnable kind of thing, or they can read, process, and write. Okay, so we're gonna take advantage of that latter possibility, right? So step 1, and we'll pass in the job repository again. Okay, here we are. Dot, and then we say how much data do we want to read per iteration, right? So the idea with Spring Batch is that it supports chunk-oriented programming. Chunk-oriented programming refers to the idea that you have lots of data. You might be reading millions of rows, and as you read those millions of rows, you might have an error, and something goes wrong, and then the service needs to, now you have a question. What do you want to do? Do you want to like abandon the whole job and mark it all as failed, or do you want to just fail that one little thing? Well, in Spring Batch, you can say, hey, I've read 999,999, but I've still got just that little bit more. Should I throw away the whole job and say it's all bad, or do I just mark that one last chunk? And the way you can, the amount of data you're willing to lose if there's an error is called a chunk. It's also the amount of data you want to have processed in batch. So I might write 10 records to the database at a time. I can do that in a single transaction. It's very efficient. You don't want to read a million or a billion records from a CSV file and then write to a SQL database one row at a time. That would be very, very inefficient, right? Your database can handle thousands of writes, thousands of rows in inserts per transaction. There's no reason to be less efficient than that. So you stipulate that I want to write, or I want to commit 10 rows at a time. And so that's the chunk size. the chunk size is up to you. It's up to your domain. It's how much data can your service handle. So I'm going to specify 10 because why not? And then it's going to be wrapped in a transaction. So I'll inject Spring's platform transaction manager. So platform transaction manager. This is an abstraction that's been in Spring forever. And so I've got a chunk, and now I specify the reader, an optional processor, and a writer, okay? So I'm not going to do the processor, but I will do a reader. And again, if you have more than one step and more than one job, you might use Java config classes for each step, and then inject the Java config class, and then call the methods on that, because you'll have lots of item readers and lots of item writers in the same Spring application. But in this case, I've just got the one step. So we're going to create a flat file item reader reading data for type dog. So let's create that domain object here, dog, int ID, string name, string description, and string owner. We don't have owner, so there you go, just description, okay? And so we'll say read data of type dog, dog flat file item reader, new flat file item reader, and I'm going to say dot builder. Okay, build, and then what we're going to say is we're going to read data from a resource, where a resource is another abstraction in Spring. How many of you have heard of the resource abstraction? Okay, this has been around forever. It's a thing that can produce bytes. Okay, where's that annotation? I got the wrong one. Here we go. I want the type, not the annotation, from Spring Framework Core. And there's lots of different implementations, resources for file systems, URLs, virtual file systems, etc. But if you're using Spring Data and MongoDB, there's a GridFS resource. If you're using, different cloud like S3 and so on, there's resources for that. I mean, there's resources for all sorts of different implementations, right? But I'm going to use a resource pointing to the file system. And where's that file? It's over here, right? Where did we say? Devox 2025 Devox, and it's called dogs.csv. So let's take this, and I'm going to tell Spring to inject this file, home, there we go, there you go. Okay, so I'm resolving, and I'm saying I've got let me move this over here, it's getting a little cramped in my little IDE, good, there. CSV. So I'm going to load the CSV, this long path. But notice that I can use property placeholder resolution within these annotations, right? I can say, give me the home environment variable. So there you go. Or I can do, if I want to use a Java property, I can use user.home, right? But on Unix, it'll be just home. It's the same thing, okay? So I'm going to point it to that CSV file. And let's just confirm that that's working. If I do that, I can say, get contents as a string, and I can print it out. Content, right? And by the way, shame on me for not doing this instead. Okay, and this throws an exception, so throws exception. Good. And we've got this, and what's the issue with that? Oh, right, it's got to be dog. Okay. So it's so I'm going to say read the resource called that. Give it a, it's going to be delimited. How is it going to be delimited? Well, it's going to be comma delimited. It's going to have names, right? It's going to have columns. So I'm going to say ID name description. Is that true? We go over here. Cat head -1, right? ID name. Okay, and I'm just going to copy and paste that. We'll put that over here. Okay. Goody. Dot split. There you go. Okay. So that's my columns, and I'm going to tell it to skip a number of lines. The first line is the row header, so I don't want to read that in as data. I want to read every line after that. Okay. And then how do I read the data? What am I going to? How do I map the data that comes in into the dog object? Well, I create a field set mapper. It's a callback, right? So given a field set, I can return an object of type dog. So new dog. Field set dot get, or sorry, read int is ID, right? Is that the field? Yeah, int. And field set dot read string name, field set dot read string description, right? So now I provide that. Okay. Now that's going to map each row, and it's going to give me a callback, give me a chance to specify how to map the data. I can now then pass that in here. So this is called, there you go. I'll just inject that type. Okay, put that in there. Dog, that file item reader. Now what about the writer? Well, and also the job itself. Remember, I want this job to have a step. Let's get as much of our code compiling as possible, as quickly as possible. Okay, I'm going to tell this to have an incrementer, so it's going to have a unique ID on every single run, so that it doesn't, there's parameters that are used to distinguish each execution of the job run, and if you don't have distinct parameters, then it won't run it over and over again. It'll just stop running because it says, hey, I've already run this instance with those keys, and therefore there's no need to run it again, right? And this is very useful. Imagine you want to run a report once a day. Well, if somebody runs the same process twice in the same day, you want the second one to fail to run, right? Because you don't want it to run. You might have processing that you don't want to have happen more than once per day, for example. So it'll refuse to run, and I'm going to trick it to run by just having it automatically increment some value that's stored in the database. Speaking of which, Spring Batch has database tables, okay? So batch initialize schema, as always. I'm going to tell it to initialize the Spring Batch tables as well, okay? So let's see if we go over here now. What about for the writer? We're going to, for now, just as a debug, we're going to have a writer that we create ourselves just to see what it's doing, okay? So it'll be dog item writer, okay? And you get a chunk, and I can just visit the records and then print out the dog data, okay? Pretty simple callback there. And I need to now inject that over here. So I say item writer of dog, okay? Dog. Try that. Oh yeah, make sure you honor the generic parameters there, the bounds. So the input into the writer, the input from the reader becomes the thing that the reader reads in is a dog, and then that's what I'm going to pass into either the processor or the writer. So in this case, it's a dog going from dog to dog, but it could be I'm reading in the dog and I'm writing out, shelter allocation or something. It's different. Okay, so what is the issue with this? Name has to be specified. Fair enough. Nice that it told us. Okay. Okay, so that looks like it's worked, right? You can see we've got these dog objects. ID is 101, name is blah, description is blah. And if you go down here, here's our buddy Prancer. His ID is 45, his name is Prancer, and he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, okay? So what we want to do is now write that out to a database. We've read it in from CSV. We want to write it to a database. So I'll create an actual item writer, not just our mock one for debug purposes. We'll say bean JDBC batch item writer for dog, okay? New JDBC batch item writer builder. And then I'm going to inject the data source. Okay. .build and for dog, okay? And here's the data source, passing that in. Here's my SQL. I'll say insert into dogs, into dog, ID name description. And I'll pass in 3 question marks here, okay? And then we do an item prepared setter to specify the parameters. So ps.set ID, and then the string 2 is this, and description is there, and 3, okay? Alrighty, let's try that again. Here we go. Did that fail? Oh, the owner. Okay, I did that wrong. Remember my schema? The owner has to be null, so null. And then drop this table. Objects, tools, drop. Okay, just drop the table. Reload. Okay, if that's worked, we have a table full of dogs, okay? So ID, name, and description. And we have no owners yet. That's the point. We're going to build software to support adopting these dogs and specifying a value there. Okay, so that's our Spring Batch application. That's how you get data into and out of a system. And you can do all sorts of things. You can run these jobs, manually. By default, Spring Boot will automatically launch the jobs when you start up the program. So if I go over here, batch job enabled is false. If you specify it as false, it won't run anything when you start the program. Right? It won't run all the jobs automatically. You can explicitly create something that injects the current job that you want and then launches it, right? So application runner job launcher, right? And then return here. And I can inject the job itself. So I say launcher dot run, passing in the job, new job parameters builder, dot two job parameters, and then there you go. So that's in effect what that property is saving you from having to do yourself, okay? So if I do that, we'll get the same basic behavior as before, but now I've got duplicate data because I've already run the job before, but that's okay. Okay, so let me drop this table one more time. We'll run it correctly. Object actions, drop, goodbye, run it again. Okay, so there you go. That's exactly what you would have gotten otherwise. And you can see that Spring Batch has these tables that keep state. It keeps track of which jobs have run, which parameters have been passed in, which instances are running or have finished, and so on. So operators can intervene and say, hey, I want to resume the job, but I want to resume from, skip the failed chunk and otherwise continue or whatever. Maybe you fix the data yourself. Or maybe use Spring AI to clean up the data for you, put it back in the database, and then resume that way. The other thing that's nice about Spring Batch is that you can actually use this with Spring integration. So you can say, hey, I want to distribute the job processing across a cluster. It's very easy using remote partitioning and chunking to start scaling out that processing across a grid of nodes, okay? Okay, so we got data in the database. Now let's build back to our initializer here. We're gonna build a adoption service, hit enter there. UAO adoptions dot, let me go over here, .zip, okay. Adoptions application. And the goal here is to write an application that talks to the database and supports adopting dogs, obviously. So same thing as before. And in fact, I'm going to do something here. I'm going to make, did I already have Postgres? I did, right? Yeah, good, Postgres. So it'll be Postgres. I don't know why the AI insists on putting in the MySQL ports, but it's weird. It's the least useful thing it could put there. Username is my user. Password is equal to secret. Okay. So I'm connecting to the SQL database. And what I want to do is I want to build an application that reduces the blast radius of change. I want to design my code in such a way to promote the scalability of the people working on it, not just the service at runtime. Okay. And this is very important because, I know you know this, but it bears repeating. The very large majority of a cost associated with software has very little to do with how quickly you can build it. It has everything to do with a long tail of maintenance, right? And so everything you can do to make that long tail cost smaller is valuable. In fact, exponentially more valuable than fast inception time. So Spring Boot and Spring Modulith have you covered in both ends of that continuum. And so we're going to use Spring Modulith. We're going to write our code in such a way as to reduce the blast radius of change. So I'm going to go over here. I'm going to create a new package here called adoptions, because again, I'm great with names. I get that from my father. He was great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, great with names, okay? So we're going to build a new service here, adoptions controller. And first problem, already, we've got a problem. What is this? Why is this public, right? That should not be public. Java is an object-oriented language. Object-oriented languages give you information hiding. The whole point of information hiding is to keep peace in the office, right? The reason you have object information hiding is so that you can make things package private or private. The more private things are, the less the more difficult it is for somebody to accidentally depend on those types, right? And that if you create dependencies across packages, you create a labyrinth, you create a web of dependencies. And those dependencies get bound up in knots. It's very important to avoid that, because those knots means that every single time you make a refactoring, you have to coordinate that code change across the whole code base, not to mention everybody else on the team who's working in the code base. You have to tell them about what has happened. So it's in your best interest to keep your changes small, private, and less visible, right? The less visibility, the less chance that somebody else will create another dependency that you have to then unwind whenever you want to refactor. The more you do this, the more things become public and the more dependencies you have, the harder it is to make changes without having long, arduous meetings with everybody else in the team just to decide how to refactor one little thing, right? And this is the same reason we have microservices. People realized that in order to scale out their organization, they needed to have a way to say, hey, this code is mine, it does only this, and I'm not changing it, and you can't depend on it. How do you do that? By creating a network service, by adding a network boundary between the client and the server, right? That dependency decomposition is very, very valuable. Not because it's easier in the simple case of making a call from one component to another, but because it makes it impossible for people to inadvertently depend upon things that they should not have access to. So I don't love that IntelliJ makes this public by default. Remember, in Java, types are not public by default. You have to go out of your way to add the word public, right? By default, they're packaged private, as well they should be, whenever they can be. So I'll make this a type called, it's a controller. And again, we're going to talk to a database. So I'll have a string name, string owner, string description, right? Let me make that a little bit smaller for my own purposes. And it'll be at ID. And I'll use Spring Data JDBC here. You can use whatever you want, JavaOQ, MyBaddis, lots of options for talking, DBI, all sorts of good options for talking to a SQL database, okay? Lots of really good ones. So here we go. I'm going to have a method here called adopt. It'll take the dog ID and the new owner's name. Now, of course, that in turn, for it to do its work, will delegate to an adoptions service, okay? And void adopt, there you go, at service, at transactional, okay? And then this in turn is going to use the repository that we just created. So I'll say dog repository, dog. Okay, fine. I'll do it myself. Okay, add that. Okay, here we go. So this repository, find by ID, dog ID. If the dog is present, then we're going to update it, right? So new dog, passing that in, and then we save it. So we say this repository at save. Okay. Whoa. Okay. io.println, updated dog. Okay. So I've updated the dog, and I've saved it, and we should see that. Now I'm going to delegate to that from this endpoint here, which is just a simple HTTP endpoint, dogs, dog ID, adoptions, okay? And I'll say dog, adoption service. There you go, .adopt, delegating to that, and voila, okay? Let's go ahead and make this a path variable, and this will become a request parameter. Okay. Now I go here, 8080 dogs, 45 adoptions. Remember, Prancer's ID is 45. Owner will be Josh. Okay. Method not allowed. It's going to be a post, of course. There you go. And it says updated the dog. We've adopted this dog, right? And you can confirm as much by going to our SQL database here. Okay. Test connection. Here we go, my database, public, tables, dog, there you go. So now you can see we've adopted this dog. Great. Is that real though? Is that a real thing? I don't know if that's actually representative of what it looks like to adopt a live animal in most jurisdictions. Usually there's more process involved than just updating one column and one table and one database somewhere, through some CRUD endpoint on the web. But hey, I think there's probably more ceremony, there's more bureaucracy, as well there should be, I think, in this case. For example, you might want to ensure that the dog sees a veterinarian. So a veterinarian is, of course, a doctor for a dog. It is a dog tour. So we shall create that type, okay? And we shall have a method here, void checkup in dog ID, io.println, checking up. Yeah. Okay, now I've got that dog tour. Let's close some windows here. Go over here. Now, when I go to the service, click on that, I can say dog tour dot checkup. Okay, and reload that. And post. Okay, and now it says updated the dog and I'm checking up on dog ID, right? So I'm scheduling a checkup as well as adopting the dog. So these things happen at the same time. But are they dependencies of each other? Is one a dependency of the other? I don't know if that's true. They both need to happen, but one clue is that there's no actual return value here. It's void. So clearly this needs to happen, but it doesn't necessarily need to happen before what I'm doing has to happen, right? So maybe this is it's a sort of orthogonal concern, but it's not a dependency. So maybe this is the wrong call. Maybe these should not have been public. Maybe I should not have created a dependency there. So let's back out these changes here. Okay, get rid of that, and that. How can I communicate from one module to another? Well, instead of doing this, I can use the Spring Framework Application Event Publisher. So let's inject that, private final application event publisher. Add that to the constructor. And now I go over here, I say this, .publisher.publish event, new, and I want to create a new event to signal from one module to another that something has happened. In this case, dog adopted event, right? And it'll be dog ID. I'll use records. And that'll be my first intentionally public type, okay? So I've made that public, and I'm going to publish that event from this component, this service, in the adoptions package, in the adoptions module, if you think about it, right? These are, I've got two root packages. These are these are modules in the ModulithExternalized system, right? So I'm going to publish that event, and then I'm going to consume that event over here in dogtour. So I'll say at event listener, dog adopted event. Okay, reload. Okay, so now you can see it says checking up on dog adopted event instead of the ID. So that's much better, and I've decoupled these two things, and I feel much better about my choice, but have I really decoupled them? Like, what happens if I do this? What if I add 5,000 milliseconds or 5 seconds to the reload time, okay? Go over there, post, and you can see that even though I've made the call, it's stuck, waiting, right? I've got one thing, but I'm somehow waiting for the other to finish before I can proceed. That implies that necessarily these things are existing in the same thread, right? They're in the same transactional boundary, which is good for if you're trying to maintain transactional integrity, but they're also in the same thread, and that's not what I normally think of when I think of messaging and the like, right? I want decomposition. So one thing I could do is I could say at async, right? At async means that it'll launch that method in a separate thread, it returns immediately, and then in the background there, eventually you'll see it say checking up on dog. There you go. So I got the best of both worlds there. I'm decomposed, but I'm also asynchronous. But I'm no longer in the same thread, am I? Right? There's clearly another thread that's being launched there, and that separate thread is in a separate, it means necessarily there's a separate transaction going on as well. And so if I wanted transactional integrity, if I wanted to make sure that something that starts in the first module continues and propagates and rolls back atomically in the second, then I've lost that. So how can I get the best of both? How can I keep my asynchronous decomposition and my sort of eventual consistency? Well, I can use Spring Moduliths at application module listener, okay? And application module listener is a meta annotation. It in turn has at transactional event listener, it has transactional, and it has at async. And at transactional event listener in turn is an event listener, right? So you're back to where we started. So I'm going to use this with some configuration here. Okay, I'm going to say I want Spring Modulith to republish outstanding events on restart. Okay, let's restart this. And I need to initialize the schema, don't I? Modulith schema initialize is true. So now, go over here, I've got 11 tables, refresh, there's the 12th, and you can see I've got this table called event publication, post, I made the call, it returned immediately, right? And now if you go over here though, you can see that in the event publication table, I've got a transactional ledger. I've got a record of event dispatches from one module in the Spring application to another. So I've got the ID, I've got the listener ID, and you can see it says dog.tour.checkup. Here's the ID. Here's the event type. Here's the serialized representation of that event, the publication date, and crucially, the completion date. When was the dispatched method finished, right? So now let's try this yet again, publish again, and reload. And you can see that for right now, since I'm waiting that full 5 seconds, there is no completion date. Okay. Now refresh again, and there it is. Okay. So now post yet again, stop the program. You can see I've got the third row there. The completion date is null, and I've stopped the program. I want to make sure that this eventually gets processed. So I'm going to restart and drink some of this. Okay. Okay, so it says checking up on dog adopted event, and eventually, oh yeah, that's it actually. This is the eventually consistent thing. It called the method, and now this is completed, right? So even though the event wasn't fully dispatched before I pulled the plug on the power the first time, as soon as I restarted it, it looked for outstanding events that were not finished processing, and it replayed those events. This is called the outbox pattern. If you have a non-transactional thing that you want to integrate in your system, you reconcile it with a transactional ledger, and so you get the best of both worlds. So in this case, I've got a transactional database. I'm using that to keep track of event dispatches in the same JVM, which are not transactional. You might do the same thing, for example, when integrating with like S3. You want to write something to a file system in S3. It doesn't support transactions, but you can keep track of which files have been successfully written in your SQL database, right? And then just retry until it's done, until it's actually acknowledged as written. Okay, so this is the outbox pattern. Here, this is Spring Modulith helping me out. It's taking a concept that we already had in Spring, the event bus, and making it even more superpowered, okay? Now, obviously, I'm using decomposition, I'm using modularity in the same JVM, and I'm integrating. If I have other systems or services that I want to dispatch messages to, I can use @externalized. Okay, this is Spring Modulith events, and I can specify all sorts of different things here. One of the things I like to use is the support. There's support for Kafka, for RabbitMQ, for Spring Framework message channels, and if you have Spring Framework message channels, you can get access to Spring integration. So actually, I think I already set that up. Did that already come? Here's Spring integration test, Spring Modulith starter JDBC, Spring integration JDBC. I don't need this, and don't need that. Did I get Spring Boot starter integration? Yes. Looks like it didn't bring in the Modulith one, so we'll do that ourselves. So Modulith messaging. Wait, let's try this. Let's do org Spring Framework .modulith messaging. Events. Maybe. Is it this one? Oh, this is so sad. Oh, this is the saddest thing. Okay, I'm gonna have to read the docs. Can you imagine? Okay, here we go. No big deal. Don't worry. It's gonna be fine. We'll probably be okay. Here we go. And go over here. This is the latest and greatest. Working with application events. This is this one. Spring Modulith Neo4j. No, that's not that. This one, surely. Spring Modulith events messaging. The reason this is actually so very embarrassing for me is because what this brings in is the support for integrating Spring Modulith via Spring integration to externalize that event to an external system. And so I'm going to specify, let's say, a channel. So let me create an integration here, class, externalization, integration, configuration. Wow, that's the First time I've had a noun with 3 yuns. Externalization, integration, configuration. That's too much, okay? But the reason, so what I'm going to do is I'm going to create a message channel. Okay, here we go. I'll say message channels dot direct, and this will actually give me a spec like that. So I'll say direct channel spec, okay, outbound or whatever, and turn that, and there we go. And I'll have a, just like we saw earlier, you can have constants, right? So outbound channel, okay. There, okay. So that's nice. I've got like this nice, I'm telling it to publish this event to this message channel, where then a Spring integration flow can listen for it, right? So integration flow from this message channel. And Spring integration is an enterprise integration technology. It's patterned off of the work by Bobby Wolf and Gregor Hoppe, okay? And it's from this amazing book called Enterprise Integration Patterns. So this book is like the lingua franca of system integrations, and it's a very nice framework. It's also the first framework, incidentally, to which I contributed bugs. Now, not fixes for bugs, just bugs. Years ago. It's my favorite. It's like one of my favorite projects, and the reason it's so good is because as we move forward in time, there's an increasingly larger surface area of systems and services that need to be integrated with. They are older legacy systems, right, by definition. So I'm going to say, whenever a message comes into this channel, I want to process it here, okay? So I'll say, I can do all sorts of things here. I can say handle, new generic handler, okay? And, I'll have a dog adoption event, and I'll then just, let's just print it out. Let's just see if that's working. So, oh, nope, I gotta train myself. Here we go, okay? Payload. Good, okay, so, anyway, this support here, messaging, externalization, is in Spring Modulith. And the reason I'm so embarrassed that I forgot the coordinates is because I wrote it, right? So like it's just not good. The memory's not good. It's not good at all. Okay, here we go. So let's see if that worked. Okay. Oh, it doesn't know which channel. Okay, remember we talked about, okay, here we go. Always use qualifiers if you need to. I just finished explaining it and then I forgot to do it. It's embarrassing. Okay, so now it's going to publish an event, not just from one module to the other in the same JVM, but it also externalizes that event by sending it into this channel, which is like a pipe, and things are going to flow through the pipe and they pop out the other end. And then here we've got the listener, which will then process it. And I can do, any kind of enterprise integration service, or orchestration and so on. So I can do split, I can do, aggregate, I can do routing, I can do enrichment, I can do aggregation. I mean, all sorts of, I already did that one. All sorts of like orchestration patterns are all supported here, and so on. So let's go ahead and go back here. There we go. And you can see the dog adoption event, updated event, and this right here is actually here. I should have been very clear. So payload, okay? And I actually have headers as well, so I can go through the headers. KV, okay? Okay, here we go. Okay, and you can see I got the payload, I got the different headers that came with it, and so on. So it's obviously working. And from here, I could use all of Spring integration. So Spring integration is all about, well, guess what? Integration. So there's inbound and outbound adapters. These adapters take data from the real world and adapt them into Spring Framework messages so that you can then process them using this nice DSL. And it takes those messages and adapts them to the real world so that you can write them out. So you can read from an FTP server, process the data, and then write it out to a Kafka broker or whatever. I mean, there's dozens of different adapters that do all sorts of different things, and it's trivial to write your own. So if you can get Spring Modulith to publish that event to Spring Integration, the world is your oyster. You can now send that message anywhere you want via Spring Integration. You have connectors, you have integrations for basically everything under the sun. So what I've just shown you is the basics of that integration. But Spring Integration is just really, really powerful. And you can do all sorts of, like I said, orchestration and so on. And in fact, Spring Integration, remember I told you earlier that you can use Spring Batch to remote chunk and partition your workloads over a grid? That connective tissue that links a batch, a leader node to the worker nodes is Spring Integration, right? You use channels to tell it where to distribute the work, and you use the Spring Integration subsystems to do that, the connectors to do that. Okay, so now we've got Spring Modulith. I think we can agree the code is now modular. It feels modular, it's decomposed, but how do I know if it's modular? Well, like all things, you just write a test, right? So I'm gonna go over here, var am application modules .of adoption application .class am.verify. I can print out the modules. I can even document the modules. So let's do that as well. Run this test. Okay. So now if I run that, the test is green, which is nice. Okay. And you can see that Spring Modulith has an awareness of the modules in the system, their dependencies, and how they relate to each other, and if there are dependencies across the different divide there, across the modules. And because it knows how things are arranged, well, it's in a perfect position to tell us about the arrangement and to even document it. So here, this is a plant UML diagram, right? I wrote it automatically wrote this plant UML diagram, which I can then use tools like GraphViz to visualize. So here's my architecture diagram. This is actually a C4 architecture diagram. C4 is a component diagram style, and this is actually automatically generated for you based on your code. So now the status quo, I'm sure, is for a lot of organizations is you log into a wiki page and you've got some diagram from some well-intentioned architect from like years ago that is no longer consistent with what's actually in production. Now you don't have that, right? You can actually have images that update automatically. You can explain the architecture of the system and see it at a glance because you've got this nice auto-generated imagery. So Spring Modulith is just a really nice project. I would start all my programs today with Spring Modulith, right? Spring Modulith also it sits on top of Spring Boot, so it brings in Spring Boot, and then Spring Boot brings in everything else, right? But Spring Modulith, this is it's a nice, clean architecture, and the reason it's nice is because it'll help you write code that stays within sort of the guidelines of good, clean, scalable architecture. And the reason it does that is because we have that validation loop here, this verify call. So for example, let's say I wanted to do something like this. Let's say I created a package called validation. It's a nested package within the adoptions module. And therein, I have another type called validation. This type is a Spring Bean, yeah? Okay, go there. And now I go here to dogtour, and I'm going to inject validation. Well, this is a cross-module dependency, right? Like I have a type that's a nested type. It's in validation inside of adoptions. So in Spring Modulith, the rule is if you have a root package, that's a module. Types within, packages within the module are private. You should only use types in validation within the adoptions module, but not in the vet module, right? Because that leaks inadvertently the dependencies from one module to another. So let me go over here, delete that, reload this test. Okay. And you can see that the test is now broken. It's saying, hey, module vet depends on non-exposed type called validation with module adoptions. So now I've got the test actually helping me catch something that the compiler isn't, right? The compiler will happily let me leak an implementation detail from one module to another, but the tests are saying, no. You're creating a knot, you're creating a dependency across modules that will only, bite you later on, right? So, you've got this nice feedback loop. I love that. Okay, so let me get rid of this. Make sure the test is green again. Okay, reload. Okay, good. So it's worked. Now, we've got modules. I've got a web service. I've been using HTTP and Spring MVC and all that kind of stuff. Obviously, there's other ways you can create HTTP. There's other ways to create services. One that you might do is to, well, first of all, actually, did I create all the endpoints I want? I don't know if I did. I want to create another endpoint here called dogs, okay? Let's just have an endpoint here called dogs. It'll return all the dogs, and I'll say return this dot dogs, okay? Now, that service doesn't exist yet. We can create it. There we are. Okay, return. There you go. And the directory is, that's every single time I run that test, IntelliJ, I need to delete the target directory. I don't know why. Okay. Oh, wrong one. I want to run the service. So now, in theory, I could go to localhost host 8080 dogs. Okay, so I've got the dogs endpoint. So this is all well and good, but there's other ways to create services, right? One common way is to use GraphQL. How many of you are using GraphQL? Okay, GraphQL is awesome. So I have a folder here, GraphQL. I can create schema, or just dogs.graphqls, and I can describe type dog, ID int, name string, description string, and I can create a type called a query, and this is a well-known type, and I'm going to say I return from this query, I return a collection of dogs. That's what the bracket syntax is. If I just have one, it's one, right? It's just one dog, but I want an array, so put that back. Now I'm going to create a GraphQL controller here instead of just a regular HTTP controller. So go back over here, and instead of having, I should rename this to be adoptions MVC. Okay, but now I'll create a class adoptions GraphQL controller. Okay, and again, I'm using @controller. It's the same annotation. Do you know the @controller annotation is a meta annotation, but it's not. It doesn't imply anything to do with the web. Controllers are just logical components that adapt some network protocol to your business logic. There's no connection to HTTP or anything like that. So I'm using it for GraphQL, but you can also use it for all sorts of other things as well. So here we go. I'm going to create a query mapping endpoint, returning a collection of dogs. Okay, return, and I'll use the dog. I'll use the adoptions service.dogs. Okay. Directory is not supported. Each time I run that test, it makes me sad. Here we go. Okay. So now I go over here, and I want to have a client so that I can interact with my GraphQL stuff. So GraphQL console enabled is true. Okay. GraphIQL, graphical. Get it? Graphical. There you go. And now it's going to let me issue queries and interact with my data. So I can say, give me all the dogs, give me the IDs, the names, hello, and the descriptions. Okay, nice. So now I've got the data back via this GraphQL service as well. So again, you can very easily create different, we have gRPC support, we have GraphQL, we have HTTP, we have all sorts of different, RSocket, there are lots of different protocols that you can use to build your services, and the programming model is pretty consistent across all of them. Okay, so we looked at Spring Batch, we looked at Spring Boot, we looked at autoconfig, we looked at Spring Framework, we looked at Spring DataJdbc ever so briefly. Where should we go from here? We looked at Spring Modulith, obviously, looked at Spring Integration. I think we're now at a point where I think it's time to like turn this into, I think we need to start thinking about things like security, right? And starting to build this up as a system. So I've got a simple HTTP endpoint here, but it's not secure, is it? Right? So what I want to do is I want to like secure the service so that people can't just make requests to my backend API. And so what I'm going to do is I'm going to create a new microservice here, start.spring.io, okay? And I shall create a new microservice called auth. And here I'll bring in authorization, OAuth 2 authorization server. I'll bring in the web support. I'll bring in Spring Security. And I think I'm happy with that as well. Is that enough? That feels like it's probably enough, right? Okay, yeah, it's fine. Let's just, whatever. We can always fix it later, right? So UAO-auth.zip. Okay. I knew it wasn't enough. You know what I forgot? I forgot the JDBC stuff. There we go. I knew, and Postgres. Just as I said it, I knew I forgot something. Okay, no big deal. Okay. Did you know you can go here, by the way, and explore? Just hit Control Spacebar, and you can actually copy and paste one file if you just want to like update your build. So reload, Command-Shift-I, auth. Let's create a simple, secure application. This will run on port 9090. Okay. And I'm going to do something terrible, something you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So here we go. Paste that in there. And what we're going to do is we're going to create a simple controller that returns a current authenticated user. Okay. So me controller. Okay. Get mapping. String me name, and I'll inject the current authenticated principal. So I'll say principal.getName. So what have I done? Well, I've created a simple HTTP endpoint on port 9090, and in order to get access to it, I need to be authenticated. So localhost 9090, and it's going to ask me to authenticate. So this gets us into Spring Security territory. Spring Security has two very important concerns: authentication, authorization. These things are orthogonal to each other. Authentication answers the question, who is the user accessing this system and service? Authorization says, what are they allowed to do once they've been authenticated? Once we know who they are, what resources do they have access, and to what parts of the system do they have access? And you need to care for both concerns. Let's suppose I have some users that I'm going to store in memory here, okay? So I'll have that, and I'll say var users equals set.of user with username Josh dot password pw dot roles, okay? And maybe I'll have my buddy James Ward. He's also here. He and I are doing a presentation or two this week. Don't miss it. We're doing 2 different Spring AI focused sessions, so come see those. And we both have, for whatever reason, the same password, okay? Let's make him an admin, let's say. And by the way, the password there is in plain text, which is terrible. So at the very least, you want to make sure that you're always encoding your passwords. So I'm going to encode them there. And obviously this is in memory, so it doesn't really do us a whole lot of good, but just in general, you want to have a password encoder whenever you encode a password and store it somewhere. Okay. Here we go. Now, which password encoder are we going to use? Well, password encoding is a kind of an art, right? So I'm going to use the password encoder factories and create the delegating one. And what I mean by that is, let's just take this first password. Okay. That's PW1. Okay. And then here's the second one. Okay. PW2. Okay. And var, because I like var a lot. Okay, and io.println pw2. So there we go. Let's try that again. So you can see that that didn't actually, that's very hard to, that's hard to read. So system, there you go. There you go. So here's my 2 different passwords. Notice that even though they're the same input, because they're salt, they are different on the output, which is nice. So what happened behind the scenes is this password encoder encoded the password using bcrypt, right? Bcrypt is an algorithm. It's today the current state of the art for encoding passwords. It's very, very secure. It's got built-in, by default, it'll take time. That time that it takes to do the encoding is a feature. It means that it takes a long time to encode, and it makes it very hard to do brute force. If you wanted to denial of service the system or try and guess the password, you couldn't do it quickly because this will take time to do the hashing each time, right? So the password encoding is very useful because you get a password, you encode it, and whenever somebody sends a password in, like in a user login form, they have to send in a plain text password. Spring Security encodes it to match the encoding that's in the password being used in the system of record, and then they compare. Well, each time you send in a password, we re-encode. And that takes a long time. It takes a second or whatever. It takes some fraction of time. And that's a feature, not a bug, right? The whole point is to make it so that it's inefficient to try and denial of service the system that way. So I've encoded these passwords and I've stored them in memory here. And you can see how what they look like when they're written out. Notice that they have this prefix. The prefix is nice because now, you know, today, bcrypt is the thing. But what happens tomorrow, right? We don't know. Maybe they crack bcrypt somehow. Maybe quantum computing comes along and upends the apple cart, right? What happens then? Well, maybe there's a new algorithm, some post-quantum encoding algorithm. So then Spring Security will switch that to the default. Well, that means that all the new passwords will be encoded using that new one. But what about the old ones? You can't migrate them, right? How would you migrate them if you don't know what they are? And if you don't know what they are, you can't reverse engineer them unless you wanted to like throw a whole warehouse of computers over hundreds of years for every single password at the problem, right? That's not going to work. So what you want to do is you want to have some way of saying, hey, when a user with a new password tries to log in tomorrow, use this new password encoder to match it. But if the user tries to log in with an old password and they haven't logged in a while, then use the old password encoder to match it. And the way we do that is we have this delegating password encoder. And then this, in turn, maintains a map of different encodings, right? So here's the different encodings that we have supported over the many years for MD4, SHA-256, for example, Argon, and so on. The default is bcrypt. You can see that here, right? So bcrypt is what you get by default. But if you have a password that was encoded years ago using SHA-256, and it's prefixed with SHA-256, we know to use the SHA-256 encoder to decode the password that you send in to try and match the old one that's stored in the user manager, okay? Well, obviously, I'm doing things in memory here. But, you know, you probably want to store things in, and you're not going to store things in memory. You probably have them in a database somewhere. So let's do that, okay? So JDBC, User Details Manager, okay? Return. There we go. So now this is going to expect two tables to be present, users and authorities. And I actually happen to have those tables here. So, and you can find the SQL file for the in the documentation and in the Spring Security source code. You can actually just get those two tables there for you. But I already happen to have them. Here's two users here, Josh and James, and you can see that Josh, that's me, I've logged in, I've got a new bcrypt password, but James, he's an OG. He's got an older SHA-256 password. So I'm going to log in here, Josh, PW. Oh, what did I do? Josh, PW. There you go, okay? Let me just make this an incognito window. So Josh, PW. There you go. I'm authenticated. Good. Now what about James? Well, he's got it. Again, he's using the old password encoder, but the system still works. Okay. But the problem is that he's still stuck on this old SHA-256. This is no longer secure. It's very expensive, but in theory, somebody could reverse this today, right? You'd have to do a lot of processing, but it's possible to do now. We know that, right? So this is not a secure encoding. So what we want to do is when he logs in, we want to get that password from the plain text, right? If he logs in and is successfully authenticated, then we know that the plain text password that he sent to us via the form is the correct password. So we can migrate it on the spot to the new encoding, right? It's the only time we have access to the plain text version of the password, after all, is when they log in. So what we want to do is log in and migrate on login, okay? So let's create a JDBC, it's a user details password service, I think. And I'm going to use the JDBC user details manager. User details password service, okay? And I get a callback here where I get the current user and the new password, the plain text password, okay? So my job is to create a clone of the existing user with the new password. So with username, user.username. Actually, no, I can just clone the user details right there, right? Passing in the new password and then saying build. So var updated, okay? I say JDBC user details manager.update user, and then I return the updated user, okay? So I'm doing that all in one go. Let's now try this. Now, one thing that's nice in Spring Security 7 coming out with Spring Boot 4 next month is that now this object here, believe it or not, has a Boolean called something like update password or whatever. And it'll just do, in effect, all this for you. Okay? Okay, so... okay, let's try it. So now I log out, Josh, PW, that should still work, good. But that's not the one that's in need of migration, is it? So now go back over here, James, PW. Now let's just check before I do that, before I log in. Remember, James is still SHA-256, right? Refresh, refresh, refresh. Log in. And now he's been migrated to bcrypt, right? So in situ migration to the new password. So good. So this is as good a way as is possible to use passwords. But don't use passwords. They're terrible. This is actually it's an anti-pattern, right? Don't use passwords at all if you can avoid them. They're not really good. And in fact, they're actually not good enough in a lot of situations. For government work, if you're doing work with the European Union and the United States, there are certain kinds of workloads for which passwords are not acceptable. They're actually, it's actually law, right? I'm not a lawyer. Very important. Just go do your own research. But as far as I understand it, these are not okay in certain situations, okay? Because they're not secure enough, and people don't treat passwords well enough. And also, a lot of the received wisdom that we all just take for granted has turned out to be false. Like today, a lot of different organizations, a lot of different governmental organizations they actively discourage the practice of periodic password rotations. You ever get those annoying emails saying you need to cycle your password every 3 months or whatever? That's an anti-pattern now. Don't do that, right? And the reason why, I mean, come on. You don't have to tell me, but how many of you have ever had you get that email, it says you have to cycle your password, you go in, you add 1, hit save, you're done, right? Anybody ever done that move? It's a very common thing. People do the worst things with passwords, right? So the real solution is like, okay, use a password manager, keep that secure, blah, blah, blah. But nobody does, right? It's just not, people don't do a good job with it. So passwords are actually not the answer. You want to avoid passwords. They're not very secure. They leak easily, and they're also hard to maintain and keep secure. And also, people don't know how to maintain them, right? They don't have any password hygiene, so to speak. So what we really want to do is have a system where if we can avoid passwords, or at least mitigate their use, that's better. So to the extent that we have passwords, do what I just did. Use bcrypt, use password migrations, use password encoding, never store plain text passwords in the database or at rest, all that kind of stuff. But in generally, we want to avoid passwords. So how can we do that? Well, now I'm going to start looking at authorization, right? So I'm going to create a security filter chain. I'm going to inject the HTTP security builder. This is going to require I'm going to throw an exception here. And the reason I'm doing this is because I'm going to take control from Spring Boot, and I'll say, no, I'll do it now. I'll do everything, right? And this is kind of annoying because in Spring Boot, it's a kind of, the auto config for security is all or nothing. Either Spring Boot does everything for you, or you take over, in which case you need to redo this stuff. Like this, the username, the HTTP basic and form login, that was what we had before. That's the default, right? But because I'm going to override some of those choices, I need to redeclare that I want HTTP basic and form login. One of the new things in Spring Security 7 is you can actually use a customizer of HTTP security, and you can then, with that customizer, you can say HTTP security.this, whatever, right? I'm just using an example here. And then that's it. You don't have to redeclare everything else, right? This would be a Spring Bean, right? That kind of thing. So this is not, I'm using Spring Security 6, so this doesn't work, but it will work soon, right? So now you have granular redeclaration of or overrides of one thing, and you still get the defaults that are in place. Okay, so I've got the HTTP security, HTTP, okay? And I've redeclared that I want HTTP basic, I want form login, and now what I want to do is I want to use these are all password based. These are 2 password based systems. What if I did one-time tokens, right? So with one-time tokens, we call them magic links. Maybe you've seen that. You log into a system, they send you an email, you click on the link, now you're logged in, right? And so the idea is that if you have access to your email system, your Gmail or your Outlook or whatever, right? then you must be who you say you are, because that's a secured system. Google and Microsoft have done a good job of making sure that you're, who you say you are, and they've got AI to make sure you're not doing suspicious logins from different countries and all that, and they've got the best security practices, and they're not storing your passwords on disk in plain text, and so you can trust a little bit more that Google has figured out how to scale out secure password management. And so rather than you trying to take on that burden of managing passwords for users, you just delegate to somebody else. Or same thing for sending a text message. Somebody, if you have access to your iPhone or your Android device, it's a very good chance it's you and not somebody else, especially since in order to access your iPhone or your Android, you have your biometrics, your finger ID, your face ID, whatever. So if I can get a text message under my phone number, it's probably me accessing that phone, right? So I can trust that that person is who they say they are, because only they would have that credential. Okay, so I'm going to set up magic links here, and I'm going to set up a a token generation success handler with a one-time token generation success handler. So let's move this over here, and you can use Twilio or SendGrid or whatever, but I'm just going to print things to the console. But the idea is the same. You have an out-of-band channel by which to communicate this link, like email or like text message, okay? So I'm going to say io.println, please go to HTTP localhost 9090/login/OTT token equals one-time token dot get token value, okay? And I'm going to then produce a response here. I'll say response.getWriter.println, you've got console mail, okay? Response.setHeader, HTTP header dot content type media type text plain, for example. I'm just using the regular servlet API here, nothing special. You can do whatever you want to send the results, okay? Good. Okay, and of course, one of the things I love about Java 25, and I think even Java 23 and 4, is I can do like Kotlin and Scala. I can just make anonymous parameters there. So let's restart. Okay, so now I go back here, and it says, hey, you've got login for username and password, but also there's this new kind of thing called one-time token, okay? So I'm gonna say I want to log in as James, okay? You've got console mail, great. Now imagine I've gotten an email. I've used SendGrid or Java Mail or something to send an email to the user with their authenticated user email. So now I click on that. Please input the token. Great. Now I'm logged in. Okay. One-time token. So let me go back over here. Incognito. Go down here. Type in Josh. Exactly. Okay. So that's pretty convenient. Much better than managing passwords and storage and security and all that stuff. Very easy to set up, better ergonomics for the user, and it's faster too. And plus, users don't have to have password managers and all that. This is way easier. They've probably got their inbox laying around somewhere that's already logged in. So this is actually a faster result, and it's better security. But it's still a password. It's just not our password. It's Google's or your company's or whatever, right? It's somebody else's password. You're kicking the can down the road, so to speak. You're making it somebody else's problem. But I still don't want passwords. So what else can I do? Well, there is this new thing, and when I say not new, I mean not that new, called passkeys. Right? How many of you've probably seen it? How many of you have heard of passkeys? Every single website in the last 2 years has been harassing me to set up passkeys, right? Log into GitHub, please set up a passkey. Log into Gmail, set up a passkey. Everything, Amazon, everything is setting up passkeys. Well, the reason they're doing this is because this is actually an open specification from the FIDO Alliance, right? The FIDO Alliance is a consortium of different industry members that are very, very incentivized to secure the web, right? So these are small mom and pop shops like Amazon, American Express, Apple, Google, Intuit, MasterCard, Facebook, Meta, whatever, Dell. These are Chase is a bank in the States. You've got Okta, you've got Visa, Wells Fargo, Yubico. They make the Yubi keys, secure USB keys, or whatever. You've got NTT Docomo, Microsoft, Lenovo. You've got just everybody, every company you've ever heard of that has any kind of money on the line. eBay, right? Fujitsu, IBM, NEC, Netflix, Qualcomm, Salesforce, Target, Twilio, Yahoo, SoftBank. My goodness, every company that has money being conducted on the internet is very, very deeply invested in passkeys because it's fundamentally a better way to secure the web. Okay, and so as a result, you saw all the major players are already there. As a result, this isn't like a wouldn't it be nice someday kind of thing. This is already here. Every major handset or iPhone or Android or whatever supports this already, right? Every major operating system supports this. Linux, Mac, even Windows. Windows. Can you imagine? Surprised me too. It really did. I didn't expect that to work. All the browsers, right? All of them. Every single one supports this. It's already here. It's not a question of like, wouldn't it be nice one day? It's already here. So we can use it, and you should use it, and it's a much better situation. So what we're going to do is I'm going to do something terrible. Again, it gets better in Spring Security 7, but for now I have to add this dependency manually. In Spring Security 7, you can go in Spring Boot 4, you go to the old initializer here, right? And I can go start.spring.io. If I'm choosing 4.0, I choose WebAuthn, right? But for now, I just had to do it manually like we used to do. Oh, so primitive. Okay, so I'm going to now set up WebAuthn, okay? WebAuthn a.rpid, that's your relaying party, right? Basically, it's a, so this is, for now, just say localhost, okay? RP name, whatever, I'll call this devox. And allowed origins, HTTP, localhost 9090. Okay, that's my current host and port. Okay, so now reload. Okay, go over here, and now it says login with passkeys. But of course, I don't have any passkeys set up. Now, what I need to do is to set up a passkey. Passkeys on Mac are managed via the Passwords app, okay? So you need to go to the Passwords app, and you've got this here. Delete that. I've got one existing. So there's my passkeys. I've got no more passkeys in my operating system. So this is stored via my iCloud federated identity, right? So I'm going to set up a passkey on the Mac, but I can then use it on my phone and my watch, my iPad, whatever. Same thing happens with Android, I'm sure. I'm sure they've figured out how to federate your Android passkey so that you can use it from your Android phone with the other end list, because there's no other devices. It's just the phone. Anyway, so let's log in. Josh, and go back over here to the that. I'm gonna log in. Okay, I'm logged in. Now I go to WebAuthn register, okay? And, I'll call this Devox MacBook, whatever, okay? I'm going to hit register. Now I've got a couple of things I can do. I can use my finger and enter the biometric on this device, which I will do. But let's say I don't trust this computer, right? If I don't trust this computer, maybe I'm in a library or whatever, and, maybe I'm Jason Bourne and I have some reason to fear that every device is being bugged or whatever. I don't know, whatever. In that case, you can scan a QR code on the device that you do trust, like your phone. And then this is also logged into my iCloud. I set up I scan the QR code. I do Face ID on this, and then it sets it up on the iCloud, right? So at no point do I ever enter my fingerprint or a password on this untrusted terminal. This is in this case, it happens to be my laptop. But imagine if it wasn't. Imagine I'm in the famous library scenario, right? Okay, so add the passkey, Touch ID. Okay, there you go, success. So now I go over here, log out, incognito, log in with passkeys. So now I'm going to log in with just my fingerprint this time. Okay, I'm in. Good. So that's not only is that much easier for the user, it happens to be much better security, right? So this is a win-win. Very rare you get both, where you can have better security and better ergonomics, better user experience, right? But okay, let's try that other flow, right? The untrusted library computer, a public terminal, okay? I'm gonna log in with passkey in this case, but now I'm gonna use my QR code. Okay, sign in with passkey. You can't see it on my phone because you just, obviously, okay? So sign in with sign into localhost on the device with your passkey for Josh saved in passwords. Use passkey. It's asking me to do my Face ID, and I'm logged in. Okay, I didn't. At no point did I touch this laptop. So you have both ways to go, but it's just a very, very nice option. It's much, much more friendly for the user, and it's more secure. It's just a good win. So now I've avoided passwords. One of the nice things that's coming in Spring Security 7, again, coming out next month, is multi-factor auth, right? So right now, this is just one factor. My passkey is one factor. My one-time token is one factor. My usernames and passwords are one factor. But sometimes you might need enhanced factors. You might need more than one. You might need 100. I don't know. The point is, you might want to be very, very sure that who this person is who they are, right? So you can see in Spring Security 7, you can say this endpoint, maybe the admin console in my system, right, has a requirement for 2 factors. So if you're already authenticated via 1 factor, it'll show you when you navigate to that admin console, it'll redirect you to the login page again and say, here's the other factor that you still haven't provided us yet. Log in, right? Or if you have a brand new, maybe you have the whole thing locked down and everything requires 2 factors. Well, when you go to that page, it'll show you, it'll log you in with 1, and then as soon as that's done, it'll dump you onto the login for the 2nd factor, right? And this is kind of interesting because now, before, like, for example, Spring Security doesn't have CAPTCHA support, right? There's no CAPTCHA support because CAPTCHAs aren't a strong enough signal that you are who you say you are. But they are a signal. They're kind of interesting that way, right? Like, that's kind of interesting to know that this is not a robot or whatever. There's some value there. It's just not enough to be the one factor. But now that you have multiple factor support, why couldn't you add lesser signals to that mix? Why couldn't you have, like, okay, I need to have one strong signal like a passkey, but then I need to have a secondary CAPTCHA just to prove that they're not a bot, whatever. So that you can, in theory, build that kind of thing up in Spring Security 7 as well. So that's coming in, like I say, about a month. It's already there. You can try it out. It's really good, but okay. So we've got security. I've locked down the system. I'm using no passwords, or I'm using very few passwords, and you can see where things would get even nicer next month. But how does that help me with my adoption service, right? This is the auth server. I've built an auth microservice here, and I've logged in a bunch of different ways. But to do what? I just have this simple controller that I'm using to prove, to demonstrate which user is authenticated. But I still haven't gotten we still have dogs out in the open, just not secured. And what happens when dogs are not secured? People ask questions. Sometimes they sing questions, ask questions like, who let the dogs out? And so we need to fix that. Okay, this is original. That song was a Spring Security talk. Okay, a song. Actually, people don't realize that. So what we're going to do is we're going to go ahead and lock down our adoptions service here. Go here, and I'm going to add the Spring Security resource server. Okay, add this. Okay, and so I'm going to say, I'm going to lock it down. Now all requests that go to the adoptions application are going to be rejected because I've installed a filter here that's going to reject any requests unless they have a valid OAuth token. So where do we get that token, and where does it validate those tokens? So let's specify these things in turn. So first of all, we'll say issuer URI resource server issuer is, hey, what the? That was somehow it showed me it showed me the correct, yeah, there you go. So it's all wrong. Here we go, 9090. Okay. So I'm going to say that's my valid OAuth IDP. That'll be my OAuth provider. But it doesn't exist yet, does it? So let's go back and turn our auth service into a valid OAuth authorization server. And so the way I'll do that is I'll say .with authorization server. Okay. Now, this is another thing that's kind of interesting. Notice that I'm using with. With is a generic fall-through DSL method that allows me to provide any valid OAuth, any valid configurer, basically. This is an abstract HTTP configure. I can provide any abstract HTTP configure as the first parameter, and then I have that as the context against which to use the DSL to configure some particulars rather. And that works just fine. But the reason we do it this way is because Spring Authorization Server is it's a full-fledged OAuth IDP. It's a separate project. It's not part of Spring Security. It depends on Spring Security, not the other way around. But that means that you get this very sort of disjointed experience right here, where I'm using Spring Security and I want an OAuth IDP, and yet I'm using a different module. It's not part of Spring Security. So Spring Security 7, we've rectified that. Spring Authorization Server, and Kerberos for that matter, are now part of Spring Security itself, right? So there's actually a dedicated DSL method in Spring Security 7 for setting up the OAuth IDP. There's already OAuth client and OAuth resource support in Spring Security Core, but now the full OAuth server itself is now part of Spring Security Core. So first of all, you get nicer DSLs and sort of that experience is better, but also you get consistent release train cycles and patches and all that, and consistency across the code bases, more consistency. Okay, so I'm going to set up an OAuth IDP. My OAuth IDP, if you've ever used OAuth, if you've ever set up an OAuth client, you go to like developer.facebook.com or developer.twitter.com or whatever, and you set up a new app. Usually they call them apps or clients or whatever, and you have to set up, is it going to be an authorization grant? Am I going to do a redirect? If so, to what service should I redirect after I have the token? All that kind of stuff. Well, you have to specify that information. You have to specify what OAuth clients are allowed in this OAuth server. And we have an interface you can implement, and you can plug in any source of OAuth clients you want. It can be in a database, it could be Java objects in memory, it could be whatever you want, right? You could load it from an INI file for all we care. We don't care, right? But for our purposes, just to keep things simple, I'm going to put it in this property file, okay? That's not very flexible. It's not very dynamic. You can't do a self-service registration of new clients that way, but for our purposes, it'll be very consistent. But if you have it in a database, you definitely could. So to keep things moving here, rather than me typing everything out by hand, I will just copy and paste. Application.yaml and refactor this to be .yaml. Okay, close that. Paste. So what have I done? I have the data source as before. I have the application name is called auth, just like before. The port is 9090, just like before. So all of that you can take for granted. Data source, goodbye. So all that is what we had before, but what I've added is this new section on my clients. I've got one client called Spring. It's got a client ID, a client secret, again, password encoder. In this case, there's no password encoder. I've got client authentication methods and the authorization grant types, and I'm specifying that once a client has gone to the OAuth auth server and they've authenticated successfully, we're going to redirect them somewhere with the token in tow. And with that token, then they can start interacting with the system. So this is like sign in with Facebook or sign in with Google. You go to some website, click the button, it redirects you to google.com, you sign in, and then it redirects you back to the website, right? So here, this is the website that we're going to redirect back to, and this is sort of like sign in with Spring Auth server, okay? So that's my client. Let's go ahead and restart. Okay. Okay, so now if I go over here, localhost, well-known open ID configuration. Okay. Here, let me just put it there. Nope. There. So this is part of the auth module that I've been building, right? But now you can see we've got these standard endpoints that are part of the OAuth specification, well-known open ID configuration. So you don't need to know all this stuff, but your OAuth clients will need this, and you can see it's working by validating that URL. So now I've got a full OAuth authorization server, just like Keycloak or Okta or Active Directory or whatever, right? But And I've got that resource server, which will reject requests without a valid token in them. But we're missing something. We've got a resource server. That's the adoptions API. That's a OAuth resource server. It has that filter to reject requests without token. We've got the OAuth IDP. But who creates the token? Who originates the request to create the token? In the OAuth world, that's handled by something called an OAuth client. So I'm going to create an OAuth client, which will then, when it sees that I'm trying to log in or access something, will initialize the dance. It'll start the dance that redirects me back to the OAuth IDP, in this case, Spring Authorization Server. I then authenticate and it'll redirect me back to the client with the token. And I can use that token to then make calls to whatever API I want in the system that expects that token to be there, like the adoption service. Now, in this case, I want that client to also be a proxy, right? So I go to this proxy. I want to proxy the downstream adoption service. But before I can do that, the filter is going to say, hey, you don't have a token. It'll redirect me. I get a token, redirects me back to the proxy. Now there's a session with a token. I now proxy, and it goes straight to the adoption service and gives me the data back. I'm also going to proxy an HTML user interface, right? So imagine I'm on, I've got a React app or Angular or whatever, right? I've got some JavaScript served on a CDN or something. I can then proxy that. So I can serve both the JavaScript and the downstream services from the same API gateway, from the same proxy, okay? So that proxy will be my OAuth client, and it'll start the flow to kick off the OAuth dance, okay? So we go start.spring.io. And I'm going to build a new service here called Gateway. I'll use the OAuth client support. I'll use the web support. I'll use the Spring Cloud Gateway support, okay? And I think that's basically it. I say that each time, and then I always forget something. So am I forgetting anything here? OAuth client web gateway. OAuth client web gateway. It's probably enough. Whatever. Okay. Send it. So and this is an OAuth client, so it's the mirror image of the OAuth IDP. It's going to have the same specification. I'm going to say, as an OAuth client, I want to act as a client to the server. And so I'm going to copy and paste the properties for that as well. So demox source, it's called adoptions or gateway, source main resources. Okay, so we go back to this, and you can see we're going to run on port 8081, and we're saying, hey, I intend to act as a user. I'm gonna act as the client called Spring on behalf of the user, and here's my redirect flow. Here's what permissions I want. Here's the secret, all that kind of stuff, and here's the issuer URI for the tokens. That's the auth server that we just stood up. Okay. So this is the client side perspective of acting as a client. Okay, so now this is going to be a proxy, like I say. So how do you use the API gateway or proxy? Well, you create routes in the same way that you would do if you were using the Spring MVC functional configuration style. So I'll create a API route, okay? Actually, let's just try something simple here first. Let's do UI route, okay? So route dot build, okay, there's that. Dot get, and I'm going to say whenever somebody goes to /**, I'm going to send them to an HTTP endpoint. Well, which HTTP endpoint? Well, I'm going to specify that in the filter that I configure here that pre-processes that request. So before filter functions .uri HTTP localhost 8020. Okay. Now, what is 8020? Where did we get that? Well, I haven't shown you yet. Let's do that right now. So, okay, cd UI. I happen to have here some HTML and some JavaScript. Now, this is the bad kind of JavaScript, the kind that doesn't work, right? So this is the one without a reasonable type system. So this JavaScript is just a single HTML page, right? Let's actually open this up, and it's going to rely on us making a call. We don't have this button, this whole ask button thing that doesn't work yet because We don't have time to show AI, but we do have 2 calls to dogs and to me. So what I'm going to do is I'm going to go back to the adoptions service here, and we'll build a me controller. So it's basically the same thing I showed you in the auth module, except it's within the adoptions API. Map string me, inject the current authenticated principal, map.of, voila, okay? So there's my simple HTTP controller. So I've got me and I've got dogs, and both of these endpoints are available in the adoption service. So when I have a API gateway, I'm gonna, we'll see it in a second. Anyway, there's that. And what else do I want to show you here? This is the ask button. Don't need this. Let's just comment that out. Okay, so there's my JavaScript, and I'm gonna serve the JavaScript. Just imagine a CDN, right? In this case, I'll just use simple HTTP server. Okay, serve. Yes. So that's on port 8020. So if you go here, it's gonna serve up the JavaScript, but the JavaScript is going to fail because it's making calls to /dogs and /me, and those endpoints don't exist because this doesn't provide them. It's our Spring app that provides them. So we need a gateway to proxy all this stuff, right? So go over here. Oh, that was it. Here, yeah, there we go. So this is going to be localhost. It's basically somebody goes to /**. We're going to forward them to 8020, and they'll get the data that's served on that, okay? And to confirm that's working, let me remove here the Spring security stuff just for a second, just to make sure the gateway is working as we expect. Oops. Reload again one more time. So now I'm on port 8081, and I'm going to serve up the JavaScript, right? So 8081 is the gateway. 8020 is the actual CDN static JavaScript that's just being served under Apache or Nginx or whatever. No Java at all, okay? So 8081 is the gateway, and you can see I'm getting the contents of that HTML page, okay? So that's worked. It's working. What about our actual, so the problem is that this is a greedy path, isn't it? This is gonna match everything in the program. So I'm gonna give this an order. I'll say order is like 10, right? Or is it the other way around? Lowest precedence, okay? So what I want to do now is I want to say I have another route, server response, API route, and this is the route that goes to our backend adoptions API. Okay, so return route dot build dot get, and I'll say anything that goes to dogs, okay, I'll send them onward to an HTTP endpoint. Well, again, which one? Same idea. I'm going to specify 8080, okay? Now, of course, it's not going to work. If I proxy anything from /dogs to the backend service on 8080, it's going to send the path. It'll send dogs. So if I go to the gateway on 8081, right now I'm on port 8081. So if I go to 8081 dogs, it's going to get sent to 8080 dogs, which doesn't exist, right? So what I need to do is to pre-process it by saying rewrite, okay? Rewrite the path so that it goes from dogs to just that, okay? Okay, so there's that. And then the other thing is it's not going to work because the dogs API behind the scenes is secure. There's a resource filter there, isn't there? So the other thing I want to do is I want to set up a filter, a token relay filter, that will reject the request if there's no token, but it'll initiate the OAuth dance, okay? And I want this route to be higher precedence, right? This one should come first, and only if this doesn't match should we then go to the catch-all, which will serve up the JavaScript, okay? Okay. So, is that working? Oh, we want to also make sure that this has the token relay. Okay. Let's see. what is the JavaScript page looking for? This is looking for dogs, and this is called dogs. Did I say, oh, I commented out the security stuff. Of course it's not. Here you go. Okay. Restore the security OAuth client and the gateway. There you go. Now you saw I went to 127.001.80.81. That's the gateway. As soon as I hit enter, it redirects me to the Spring Authorization server. So now I'm doing sign in with Spring Authorization server. I can sign in any of the different ways. And now it's redirected me back to the OAuth client, right? Now, why is that not working? Oh, I screwed up the JavaScript code. See, this is what you get when you deal with JavaScript. Type error, null is not an object, ask button. Well, who did that? I have only myself to blame. Okay, so this one, and then thank you, whoever called that out. Okay. Oh, I made it worse. Yeah, well, I can see my name, so the me endpoint is working. Okay, serve. Okay. What did I do? Wait. What? Am I better off if I just restore everything? No way. Dogs.forEach. That's wait, dogs. Did I? Feels like that should be working.
Isn't dogs considered a promise?
Is it? Yeah, but it's using async await, so that should be fine. Well, what's the issue? It's not letting me for each. I guess I can always just try. Oh. Hello, console log, my old friend. Clear filters. Aha. So is that not working? If I go to dogs. What does it think I'm asking for? Well, yeah, but it's going from the gateway. It's being rerouted by the gateway. It's being rewritten by the gateway, right? So here, is it this? Yeah. Let's just try it. Nope. Wait, actually the me endpoint is clearly working, right? Dogs me name. Okay, so what did I do differently there? Sorry, what? Where? Here? On line 30. No, but that's a good point. Yeah. Oh, I don't think it does it? You wanna try that? Oh. Wait, you're right. Let's just try it. Let's try that. But why would that have mattered? Oh, because it's not doing that. Well, what about me? How come the me endpoint is working? Oh, the me endpoint. Oh no, that's still gonna. You're right. That's still there. Does the me endpoint still work? If I go over here. Oh, this guy fixed it. Thank you. Look at that. Okay. I don't even know why that worked. Is it, so was that this? Is that the issue?
If it works, you don't touch it anymore.
That was it? Oh my goodness. Okay, look at that. Nope. Okay. There we go. Look at that. Okay, so we've got our authenticated data. We've got all the dogs, okay, coming in. But now I'm logged into a console for me, Josh, right? And what I want is actually just the dogs for me. I don't want to see all the dogs. I want to see the dogs that I've adopted, right? So let's refactor this. Remember, there's an authenticated user being propagated from the gateway to the downstream service via this token relay. The token relay is a filter that adds a header for an authorization header that gets sent to the downstream adoption service whenever we make a request. That's happening automatically. So what I want to do is I want to take advantage of that new knowledge. I'm going to go back to the dogs endpoint here, and I'm going to parameterize it with the current authenticated principal. And I've got this dogs service. I'm going to pass in the the owner name there. So I'll say string owner, and I'm not going to do find all. Instead, what I'll do is I'll say, where's my dog repository? Over here. Oh, this one, same thing. Principal. Okay, but what I want, where's my repository? Repository, there we go. Here, I'll create a new method, collection, dog, find by owner, okay? So now when I go to the controller, here, and then find by owner, passing in the owner. Okay, and now I got just the owner for Josh, just the dogs for that one authenticated user, end to end, okay? I'm going through the gateway. I have the current authenticated user. I have a token that gets added to the header that gets sent to the downstream service, which then I'm able to use to derive who's making the request, and I can use that to then inform the responses that we get back. Is that so far so good? Everybody understand me on that? End-to-end security. And by the way, like if I log out, you know, remember, all of this is being driven by, I can use passkeys, I can use one-time tokens, I can use all that kind of stuff. So it's actually end-to-end integration through the power of your fingerprint or eyes or whatever. I mean, it's a really, really amazing result here. And by the way, the code, the JavaScript, the bad kind, not the good kind, the JavaScript here is less complicated because remember, it's being served under the gateway. So from the perspective of the browser, I'm only calling the gateway, and the gateway is proxying data from the JavaScript and from the API, right? It's calling the CDN and the API, but it's serving both under one host and port. So I don't have cores, there's no cross-origin scripting, and I don't have to propagate JOT tokens around because the browser will never even see this HTML page until I have a valid OAuth token, right? So the JavaScript isn't managing, you know, token propagation or anything like that either. So this JavaScript is very easy to write. It's very easy to understand and test, and you know, very, very secure as well. So finally, since we have only 11 minutes, it's time to, you know, focus on getting this ready for production. Okay. So a couple things that I want to make sure we're on the same page about here. Let's just build a scale service or whatever. Okay. I'll build a simple web endpoint. Okay. CD downloads UAO scale.zip. Now, application.properties. A couple things. First of all, take advantage of virtual threads, right? I'm going to be doing a couple of sessions on AI this week. Come see them. That AI, you know, when you're using Spring AI to talk to different models, you're making network calls. What do those network calls do? They make calls to other hosts and ports. They do I/O. Bytes are conducted back and forth from the client and the server. And during that time, you're monopolizing a thread. That's bad, right? Thread monopolization is bad because threads are a precious resource. Or at least that used to be true before the Java team, who are awesome, gave us the gift of virtual threads, okay? Now, virtual threads are, I could not be more sincere when I say I think they're probably the most amazing thing added to Java since Java came out ever, right? They are a magic trick. They are free scale. You have no reason not to use them. They're free. Just use them, just enable them and go. And they are, for the first time, and let's be honest, probably the last time, the best example of Java adding a feature that is not just as good, but better than what we have in other languages, okay? This won't happen again. Java never has features that are better than other languages, but it does here. This is an amazing result, okay? So the way you use them is by just using a new virtual thread task executor, right? Like that. So That's enough to get the job done. You just switch the executor that you can use, and you'll get that result. Let me show you an example here based on an example that I stole from my colleague. Her name is Cora E. Berkeley. She's like she's 1,000 times smarter than I am, but she's also a much better teacher. So I follow her tutorials and blogs and all that, and just a brilliant person. So she gave me a demo that she didn't give it. I stole it, and then I asked for permission, and she said I could use it. It's a good demo, and I'm going to show that demo to you here, demonstrating the power of virtual threads, okay? So what I'm going to do is I'll create a virtual threads controller, okay? Response body, okay? And I'm going to create a simple controller, and when you call that endpoint, what we're going to do is take note of the current thread. So thread.currentThread, okay? And then we're going to call another service, which is going to block artificially for 5 seconds, okay? So I'm going to inject the current REST, I'm going to inject the REST client there. And then I'll say this.http.get.uri http localhost delay 5, okay? Retrieve body string.class and var results. And then results, and I'll say s equals thread.currentThread, okay? And I'm going to print out the before and after thread. Note that I'm taking note of the thread name before I make the long-lived 5-second call and after, okay? So this call, this network call, is going to take 5 seconds. It's just a long time. And during that time, I'm executing in a thread. This web server on my Spring MVC controller is being handled in a single thread, right, from top to bottom. So I Spring MVC, the Tomcat container gets a request, the servlet gets woken up, the servlet finds this controller, and then inside that thread, we produce the bytes to send back to the browser or the HTTP client calling our service. And that all happens in one thread. And during that time, we're making this long-lived 5-second call to another service. It could be a database, it could be another microservice, it could be whatever, but the point is it's taking a long time. So let me make that. So, and then I'm going to print out S, and I'll return the results, okay? So the other thing I'm going to do is I'm going to limit the number of threads I have to keep my example more realistic, to match the resource constraints that you have in a typical production environment. Oh yeah, port has to be something different because I already have that. So I'll call that 8082. Sure. Now, what is this downstream service that I've got that I'm calling? I'm gonna stand up a Docker image here. Desktop misc talk, okay? HTTP bin, and all this is just a Docker image for something called HTTP bin, okay? So it's a way to test HTTP protocol stuff, and it's going to run in port 80. So localhost 80 delay 5. So when I go to delay 5 for 5, it'll artificially prolong the time it takes to produce a response for 5 seconds. If I say delay 3, it'll prolong for 3 seconds. You get the idea. Okay, so that's up in there, and let's go ahead and okay. Now we're going to do some load balancing, or load testing. So hey, minus 40. 20 concurrent requests to localhost 8082 delay, okay? So I'm going to go to my Spring MVC application. It, in turn, what happened there? There you go. I'm going to localhost 8082, which is my Spring application. It's called Scale application. It, in turn, is going to launch requests to the downstream service, and it's going to block, okay? And I've got a limited number of threads here. I've only got 10 threads in my Tomcat, right? So you can see, however, that when I launch a request, here's, remember, I'm making I'm making as many as 20 requests concurrently, but I've only got 10 threads. So I can only do 10 at a time. And then when they're done, I can start the next 10. So somebody has to wait in line, okay? And when I've done that, I've got these results. Let's go ahead and copy the summary here. Okay, very good. So, yuck, okay? No virtual threads. Now, what about with virtual threads? Well, again, it's trivial to enable virtual threads. So I say virtual enable is true. Reload, Okay. And now I'm going to rerun the same exact test. Okay, now, there we go. There we go. So total time with virtual threads was 10 seconds. Total time without it, 20 seconds, okay? With virtual threads, the slowest request, again, each request should take at a minimum 5 seconds because it's going to wait for 5 seconds to get their first byte back. But with network latency and whatever, it's going to be 5 seconds plus. So that in theory, if every request was about 5 seconds, that would be good. But of course, we don't have enough threads for that without the virtual threads. So without virtual threads, the slowest request is almost 3 times slower than the fastest one. That's bad, right? Over here, the fastest is 5 seconds. Over here, the fastest is 5 seconds. The slowest is about 5 seconds, 5.2 almost, right? But that's still pretty good. You're still 5 seconds compared to 300% of that, right? The average without virtual threads was 7.5. With virtual threads, it's 5, right? Virtual threads is giving you free scale. It's just an amazing result. So you definitely want to turn on virtual threads for everything that I showed you today. Just enable it just set up that property. It wasn't hard. The next thing I want to do is to turn this application. I want this application to go fast, right? And so obviously Java is very fast and it's very efficient, right? So here's this amazing one BRC challenge. This is a competition last January in 2024, asking people to write a program to load 1 billion rows of weather station telemetry data, okay? About 13 gigabytes. And no, you couldn't have used Spring Batch for this because the rules precluded third-party libraries and all that. It had to just be stock standard JDK. So the fastest entries were really fast. Again, it's 13 gigs of text, but the fastest results were like 1.5 seconds, 1.58, 1.6, right? Java is really fast. One thing you'll notice, however, is that a lot of them are using GraalVM. And I love GraalVM. By the way, I'm doing a talk with Thomas Wertinger, founder of GraalVM and a vice president at Oracle, this week here in DevOps about Spring GraalVM. But nonetheless, I want that to work. So I want to use GraalVM here. The only problem with GraalVM is that the compilation sometimes takes a long time. And so I get really bored of waiting. So I did ask, I said, hey, Oracle, GraalVM team, would you please play elevator music during the compilation, right? And I was hoping that they would merge this, and it hasn't happened yet. So eventually, Richard Fichtner in the community, he took heart to my plight, and he built a Maven plugin that will play music for you, okay? And so what I'm going to do is I'm going to use this amazing Maven plugin here with this build, and we'll create a quick GraalVM image here. So go over here. Plug that in, specify 2.0, I think is the current version. Okay, now, and by the way, see this? This is the virtual threads. So it says virtual thread number 2, 92, Tomcat handler 9, and then fork join pool 1 and 11. So that's the before thread. The after thread is fork join pool 1 and 12. So magically, the system moves from one thread to another in the same code block, even though I didn't do anything, right? It automatically unmounted from the actual thread and moved to another one. I forgot to show you that. That's amazing. Okay, now let's create GraalVM. Native images, okay. Maven, skip tests. Native compile. Okay. By the way, all these years, no audio? Yeah? Now I'm so sad. Wait, this might be it. Can you hear that? Okay, perfect. There you go. 30 seconds later. By the way, don't use the Maven wrapper, the Maven daemon with this, because that Maven daemon constantly rebuilds whenever there's code changes, which means that song just plays all day long. Can drive you a little batty. Okay, so target, here we go. Here's the build, du -hs scale 73 megs. That's static link, self-contained. Go ahead, restart, 0.04 seconds, right? There it is, 0.023 seconds, more typical. More to the point, there's a process identifier. Resident set size, that's measured in kilobytes, divide by 1,000, 73 megabytes of RAM, okay? So it's a trivial application, just a web server, but my point is, you can, even with the adoption service, that would have been 150 megs of RAM, right? And it would have started up in less than 1/10 of a second. The benefits you get with GraalVM are amazing, okay? So, yeah, definitely make sure you take advantage of all that as well. Okay, my friends, we looked at stuff. We looked at Java 25. We looked at JavaScripts, the good kind. We looked at Spring Framework's basic configuration. Looked at Spring Boot 4 a little bit. We looked at Spring Modulith. We looked at Spring Boot auto configuration. We looked at Spring DataJdbc. We looked at Spring Batch. We looked at Spring Integration. We looked at Spring Security. We looked at WebAuthn and passkeys and one-time tokens and OAuth and the Spring Authorization Server. We looked at Spring Cloud Gateway. We looked at production-worthy concerns like scale and speed, and here we are. And also, we did it in record time. I hope you got something out of it. I have a question for you. Who learned something new? Who had fun? All right, well, so did I. Thank you so much, everybody. Please vote. Please vote. I'm begging you, please. I've been doing this for a long time. I have no shame. Please vote. I'm begging you. I'm begging you. Vote. Come on. Bye, everybody. I'm doing a workshop later, another one after this, on Spring AI and AWS and all that. It's after lunch. It's not going to be the worst mistake you make. And that's actually a deep dive. You can actually hands-on and all that, so it'll be fun.